I get the screen off of my Streamlabs? It's been a bit. Hold on. I'm streaming, yes, but how do I get this off my screen? Schedule, sure. If I go to YouTube, will it show my stream? I don't even know. Man, how do I get this out of here? Oh, this is so tedious. Also, does my mic work? Not sure. There's a lot of variables going on here. Oh no. Oh no. Oh, here we go. Okay, I figured it out. Sweet. Okay. What I want to see is if my stream replay works or not. Because I have no idea if it will. Okay, looks like my stream exists there. What I want to see is if my stream replay works or not. Because I have no idea if it will. That's a little bit too quiet for my liking. Can I increase the mix? Ooh, not quite. Because I have no idea if it. It's also a bit of a delay on that stream. What if I... What can I do? I guess I mean, the stream can always get turned up from the user's end, but this is on max over here. It will. Like, that's pretty quiet. I feel like it should be louder. I guess I mean, the stream can... Yeah. Hard to say. It's hard to say how it should or shouldn't be louder. What if I'm maxed out on my OBS. Oh wait, am I? Maybe I'm not. Wait, no, it says 100. Yeah, no, I'm maxed out over here. Global settings, maybe? Nope. Nothing new. Oh well. Someone just have to let me know if it's too quiet, I guess. But that's okay. Let's put the music back on. Just some random music. Turn it down just ever so slightly. Okay. And then I might pop out live chat because I get sometimes my mixer that shows all the chats. It's a little bit out of sync. So I'm gonna throw this off to the side here. Okay. Maybe we'll come back to that. Alright, so our stream is set up. We're live. We're ready to go. Actually, maybe I'll put this... put this here from now, actually. Yeah, that's better. Okay. Let me swap over and get settled here. Hey.
Oh, it's been a bit.
But we're here to make some stuff today. I don't really know what we're gonna make, but I said we're making a drum machine. So we're at least doing that. Now the problem is this is a long project that's not going to be done in one single instance. I wonder, hold on. Let's uninstall this. If I open up some code, is it gonna be, okay, this is the default theme. Let me change my theme here. I wanted to pick a theme that's like kind of easy to see on stream. A little bit easier on the eyes maybe. Also has a little bit of a contrast. I think it shows this one last time. Yeah, that's right, I'm back. Oh, what is that? Hold on, what's that emote? What is that emote? Oh, it's Emily. The circuit cam. Yeah, you like it? You like this setup? Hold on, wait for this. Boom, full screen. We got the circuits, we got our STM right here. That's right, that's right. STM and then our little waveform space. Right now we have it hooked up so that way we can have UART communication. Because this chip has a couple of UART channels broken out, but yeah, I was testing out some UART stuff, and I mean, at least right now I can do TX, transmit, but we're trying to make it do receive now. That is the next step. So I need to add a function for that in my BSP library. So let's see. I gotta get situated a little bit here because things got a little bit moved around. Like I zoomed this in a lot more than, oh, I forgot. I gotta put back on the dev screen, lol. That's something I'll need to get used to. Okay. So right now we have our header file open and we need to add to our module. I'm looking at my preview here to see how the colors look, and they're pretty bright, so I'm kind of glad that this came out the way it did. Because I had a few different color schemes I was trying out. There's one that was like fully purple. I was like, oh, that's cool. That's like Twitch colors, but it's not as easy to see. But okay, yeah. Anyways, here we are. So what I plan on doing is making this RX. Oops. Hold on. Am I able to do it? How do I open a new window? I'm just on Firefox. Guess I could do this. Here we go. Okay, this will be. What's an easy way? I guess maybe this is how we'll do things. Just kind of like have it a little bit smaller searching. What do I need though? I need the data sheet actually. That's my Adobe Acrobat. Okay. The key to our stuff here today is gonna be in this document right here. This is our friend. No, I just reinstalled this, so maybe I shouldn't have canceled that. Oh well. Anyways, I need to make the trusty receive function that allows us to get data serially, because right now it does not. It can only send out data, and that's good for half of the situations. So what we need to do is go to the UART. Here we go. Go to the UART and actually read just a little bit on what we need to do. Actually, maybe I should do the two-paned view. Now that I'm not in vertical mode. Yeah, this might be better. I've never tried to do it this way, but ooh, that's not really easy to see on stream, is it? It's a little bit small. Okay, how about, yeah, maybe I just do one pane. I think one pane is the way. Then we zoom in a little bit. Some of this can be readable. We do this. Bring it down to here. That good? Maybe. Let me bring it out wider. It's a little bit hard to read. I think it's not readable until it's like right about there. Means I need to make it wide enough to fit that. Yeah. It's gonna be a little bit of a balancing act, but that's okay. I guess what's important is if I need to show something, I can zoom in when I need to. But anyways, we're here looking for the register that we need to talk to if we are receiving stuff. So likely it's just going to be something pretty easy, where we look for a byte that talks about, that's good, okay, good, thanks for the feedback. Likely just need some kind of register that has some kind of flag or interrupt. Likely we'll just do a flag for flag implementation first. I'm just looking here what we got. So our data comes in here. No, sorry, our data is going to come in through here, which looks like goes through our arc shift register. Even though it says they swap, in reality it's RX to here. So RX is coming into a shift register, which we can make it go through FIFO. And it looks like we had to go to this register right here, this RDR. This is where the data register, I'm guessing is what it stands for. So our data register is going to be stored here, but there might be sometimes they have a flag that pops up too. It looks like this one might not show it, so that's okay. We have a section that talks about receiving, where it says we can receive some data. It has a start bit. Okay, here we go. This is what we actually need right here. So we have a graph, and we have some particular section that should be receiving. What I'm looking for is not really this graph, though. Usually they have some graph that talks about the timing diagram. I mean, this is kind of a timing diagram. This is just talking about how it actually does the sampling. Sample-wise, we're just going to trust that the manual mode is fine, because I think this is for automatic detection. We're going to give it a fixed baud rate of certain past value first. Okay. So, program M bits into this control register to define. Okay, so this is initialization of how big your messages are. Set the baud rate, we've already done that. Set the stop bits, we've already done that. Enable USART, which we already did. I'm not using DMA right now, but that may be relevant in the future. I'm not so sure at this moment. I'm also just getting USART so that way we can debug if we want. Set the receive enable bits in the control, and it figures when it should start searching. Okay, so this pretty much from 6 on is where we're going to be doing something. So let's go ahead and open up our... Holy cow. I'm good. I'm good. In fact, I'm probably just gonna ban this person. I feel like that's a bot, so yeah. There you go. See ya. I don't deal with channel promotions in another person's channel. That's kind of messed up. Anyways, back to me. This is all about me, not you. We could go and make a function, not in GPIO. I just realized we were in the totally wrong file. Here we go. So we have send buff right now. We're gonna need to make one function that is for receiving. So because I've practiced a bit since the last stream, I got my Vim hotkeys on lock, so I can do this a little bit without using my mouse, which is pretty nice. Pretty nice. So we're gonna change this. We have some Doxygen comments as well. We're gonna receive a buffer. Actually, should we do buffer or just a character first? I think we should just do a character, just to get this idea kind of flushed out. And there was a testing I wanted to do because I made a function that sends a whole buffer, but I feel like it's a little bit scuffed. Actually, I don't even think I tested it. Now I'm thinking about it. So that's something I'm gonna have to figure out later, but it's okay. Anyways, we receive a buffer. We're going to receive a buffer of fixed length. Actually, no, not a fixed length, just receive buffer. This function probably is ideal if it's used in some kind of loop of some sort. So we're gonna have to think about that implementation just a little bit. But anyways, this is gonna be a outgoing, incoming data buff storage. So we're gonna pass it a buffer that we can later access. Incoming data buff. Sorry, I've been a little bit sick over the past month or so might hear a little bit of coughing, unfortunately. Data length, we're not going to know this, so we're going to get rid of that, and yeah, that's fine. I'm going to change this to be called, maybe I should do TX buff, thinking about it, instead of send buff. I feel like RX buff and TX buff is a better name, so we're going to change our function really quick, a little bit on the fly, no, but nothing that we can't handle. TX, okay. And then of course we're gonna have to go inside of our actual C file and update those names real quick, so that way we do not forget later down the line. I think it goes around like line 80 or something. No, it looks like it's down a few more. Let's jump groups of 5. Okay, here we go. So we're gonna name this TX char and down by 5. Usart TX buff. All right. This one hasn't been created yet. Oh. TXRX. Okay, yeah. Oh, we're gonna need to update the parameters on this. I just realized. So usart. Gonna name this RX, and we're gonna delete this parameter. Okay. So let's see, do we want to copy this? At least copy the header. Oh, actually, we can copy from this file. That's better. I don't want to get all the extra jargon. So go to visual mode, and then we'll drop down a few lines, and then jump to the end of this line. We'll yank it. We will paste it at the bottom of this page. All right, now we have our function. Now we can write actual code. Delete this line. We're gonna go ahead and go to the last, and delete, and enter onto a new line. Here we go. So usart RX buffer. So what we saw there was it needs to at least set the enable bit of this register. So we're gonna go ahead and point to that register exactly, which looks like, oops, wrong hotkey. It is in the receipt. Oh, thanks for the 5 months, Phil. 5 months. We love that. Thank you, thank you. Okay. I think that might be the longest Prime sub out of everybody. I think Phil has the longest. Anyways, thank you again, Phil. So, usart, it's in the control register. That's the name of it. So we need to make this go into the control register 1, which will be where the RE bit is. So luckily, because I have everything linked up properly, I could probably just call this macro that has already done the bit shifting for me. Usually I do the name of the register and then, sorry, the name of the hardware, then the name of the register, and then finally what the actual bit is, which is already in this case, and we can see the hashtag defined, it's already there. So we are good to go. Let's go ahead and append a semicolon. So this is enable receive bit. No, enable, we're gonna enable our receive register. Maybe that's a better name for it. Maybe begin searching. I like that better. Enable receive hardware. We'll just do that. Okay, so when it's received and FIFO is disabled, this bit indicates that the content in the shift register is being transferred. In other words, data has been received and can be read. So when it's set, we can look in the register. We're going to skip this case, but we are looking for this case. So let's go ahead and put a find for that. So we're going to do a while loop just for easy use for right now. We need to make sure we're actually talking with the hardware correctly. So we're going to do a while. They said it's set when it's ready. So while it's not set. So while you start, what's the register? RXNE bit in the RDR register. Okay, RDR RX. Oh, RDR. They're saying there's no RX bit. Okay, so that's where we come into here then, and actually look at the register to see what is in the RDR register. I'm gonna guess this is not in this register but in a different one, because it looks like it's shifted into the RDR when it's actually ready. This might be in like the CR register, but they didn't really say right here, so we're gonna have to look a little bit. Looking for RX. Okay, that's RX, but not quite what we're looking for. We're at number 2. Number 2, nope. Actually, I think I remember they put the stuff in the status register. Yeah. I see TXE. Is it RXNE? Was that it? It could be. Let's see. Scroll down to RXNE. RXNE. Read data register not empty. This bit is set by hardware when the shift register has been transferred to the data register. It is cleared by reading from this register. So it looks like it must have been this. So we need to see when this is 1, because when this is 1, then we can actually read the data. So while, which this is in the ISR, so the ISR at the bit called RXNE, which they already bit shifted here at this define. So while this is 0, we'll want to sit right here and just loop, 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 loop. So while this is not true, meaning it's 0, we don't do anything. But as soon as it turns to 1, we can actually read the data register. So this is where we go to our data RX, and we're going to read directly from it. But we need to dereference this and actually take the data out of it. So we get looks like the RDR might be just directly looking at it. Yeah, so we can take the actual address here. USART RDR, and yeah, we'll start that. So USART RDR will give us the address. It looks like we need the actual RDR section, which will just get the bottom 8 bits. Okay, yeah, that's perfect. But what we want to take is take the contents of this register and shove them into this variable here. So that way we can actually read the data later on. All right. So we're going to we're going to wait until all data has been shifted into RDR. Store, transfer. Maybe do them separately. Transfer contents of RDR into external. Alright, let's say accessible variable. Okay. So then likely we're going to need to turn off this receive hardware when we don't want to receive stuff anymore. So disable receive hardware. Simple enough. You start CR1. I actually want to clear it, so we're going to go ahead and do this bit shifting operation where we toggle the value and force it to be 0. Because this sends a 1 to that spot, and hold on, something's off here. Is this right? I need to do one shifted over. This is for access. Okay, never mind. This is for writing into this register. Yeah, never mind. This is fine. I was having a little bit of brain fart there. Okay. We're also going to do a return 1. I like to put these in all of my functions before I add any troubleshooting stuff. It's going to return 1, meaning that if you put this function inside of an if statement, it's going to pass by default. Alright. Now how can we test this? Likely, we're just going to need to set up some kind of situation where we can... We're going to need this thing to talk to our chip, and then we look at the waveform. So, I like to use this tool here called waveforms. Once it loads, then begins. Okay. Can I make this bigger? It looks super small. Never actually tried. Or like the resolution or something. Settings. Over here, all the same settings. That's not good. Window. No, it's just all small. That sucks. What about if I do this? I mean, you see in this oscilloscope, you can't really see any of the settings, unfortunately. That's a bit of a bummer, not gonna lie. Even if I zoom it in like that. What about view? Add zoom. Oh, that's for that. Dang. Okay, well. Fortunately, we're just gonna have to stick with this. Alright, even though you can't see on the side here, I'm gonna make it so I can send out logic. No, not logic. We need to send out a pattern. Pattern? No, sorry, also wrong. Where is it? It's a per call one, I think. Yeah, here we go. Per call. UART. IDs, what I got. Green is set up to RX, and green is DIL1, which is good. TX is going to our RX. This is our TX, is going to our RX on here, which is this white one. Oh, wait. No, sorry. TX is matching to TX right now. We need to swap these. Okay. So we can receive and we can send. So if we send 1 byte called 5A, we should be able to see it, assuming we have the same settings, which we will make sure our code does. So that's going to be our test bed for that. How can we validate this? Well, first of all, we're going to need to make an example. We're going to make an example so that can actually call this code. So we have a USART here that I've been working on. And right now, all it does is toggle the LED and send out a message every second. This is fine, or 100 milliseconds. This is fine for now, but I think what I want to do is have this thing receive a byte and then send it out immediately after. So what we can do is we'll yank this line of code. Okay. We will yank this and place it underneath here. And then we're going to change this to be receive character and change this to be TX character. TX character. Maybe what we'll do is, you know what we should do is take the data and then like send it, flip it, send the opposite of it. That's probably better. Okay, so we're gonna have this loop here. We receive a character, loop here, we send a character, that kind of thing. But we're going to, let's see. We're gonna remove data buff. What we want to do is up the contents of this. Oh wait, no, actually that's fine. We can pass it in there, but we want to flip it here. Now I'm curious if the code will flip it, then send the address. So I have a feeling that's not quite how it works. I think I need to do a separate line just flipping it, and the fact that I'm getting a red squiggle right here tells me that's gotta be the case. So we'll create a new line here where we do data buff is equal to inverse of data buff. Oops. Alright, so we toggle our LED every second. Oh, I just realized I don't have a cable. Sorry, just grabbing a cable here. We need a cable going from our device to the computer. I seem to have tied up, so bear it 1 second. Let's go. Welcome, Johnny. Welcome, welcome. Okay. I never actually got to see how it looks. Okay, it looks like there is color. Here we go, circuit cam. There is color. here. I wasn't sure if it was gonna be like flickering at a weird rate. So it's not actually at 100 milliseconds. I haven't fact checked if that's quite correct or not, but it is a blinking light. So what we gotta do is program this. We come in here and we do clean all our stuff because I built some stuff yesterday. Then we go ahead and do, let's make sure that's char. Okay, yeah. Go ahead and do make. We called it usart, so we have an example called usart, and we're gonna do it with 4 processes. Okay, we got some compile errors. Let's go and see. Warning, implicit declaration. Okay, looks like we forgot to name something. TX. Oh, it's because this one's called buff. We should call it char. Char. And make these char, because that's what we said we wanted to do, of course. Actually, take this lowercase. Receive char. Oops. Still getting used to the hotkeys. This one should be char as well. Char. This should be char too. Maybe not. Data RX is fine. Incoming data. Incoming char. I'll say that. Incoming char. Data RX is fine. I'm okay with that. Transfer char and RDR into accessible variable. Okay. Make sure this is good. This one should be incoming. Char. Okay. All right. So let's go ahead and clean it up again and make. We still got something. What else are we missing? Conversion from short unsigned int to uint 8. All right, well, let's look at that. On line 196 here. Oh, okay. This has to be greater than... Okay, so this is actually 9 bits, just in case you do make a 9-bit variable, but I don't. You hate those errors, Ken? Welcome to the stream, and it's okay. We have lots of experience with these kinds of errors. So basically, we just need to... We need to truncate this to actually be uint 8. And then we'll be fine. But we also want to make sure that we are taking the 8 lowest values, because this has 9. It's not values, sorry, bits. This is a mask for 9 bits. We want to, just in case it would cut it off. I think this should do it already, actually. Yeah, that should work already. Okay, we'll keep it like that. Anyways, we'll go back to here. We'll do make cleaner, so that way we get rid of any files that was made previously. And then we're going to go ahead and make our example called usart and run it with 4 threads. Another error. Undefined reference here on line 30. I probably misspelled something. I think this is char in the H file, but maybe not in the C file. Yeah, we need to replace that. Char. There we go. Okay. One last time. You don't really need to make clean every time. In fact, I probably will stop doing that from here on out. But as you can see here, there's no failure. It's just a warning that we always get, and it's not really a relevant warning, so we can just ignore that. So we come into here, our code I compiled, and here it is, usart.elf. So what we can do from here, I hooked up my makefile, so I can actually just type in stmflash usart.elf. And it failed. Why did it fail? Let's see. File does not exist. Well, I'm not trying to write. Oh, I remember now. We need to say that, hey, we are setting our program to be this file. There we go. Okay, so let's go back to BSP. BSP means board support package. It means you're writing a library or code that is just handling the basic parts of a chip. Nothing fancy, just a chip. So let's go ahead and open up our waveform. Yeah, I really wish I could zoom this in. This is actually oh, hold on. Yeah, this is like impossible to see on stream. Oh yeah, the resolution and the ads. Yeah, I'd imagine YouTube would be a better viewing experience, to be honest. But yeah, I forgot about the ads thing. Let me go check to make sure they didn't spam my stream with ads that aren't normally there. There's gonna be some ads, unfortunately, but let's see here. You went through 2 already? Oh my gosh. Freaking Amazon. What is it? Hold on. This actually has defaulted, I think, to more ads than I normally do. Pre-roll ads, but no mid-roll ads is what I wanted. Total minute of ads to show viewers every hour. 0.5 minutes. So 30-second ads. Okay. Add notification in chat. Yeah, I guess I'll do that, maybe. Yeah, I'm not sure how I can do this. Hopefully it's good now. You haven't had too many, but you don't have ad block. Is it the streamer or viewer that has to pay to remove? The viewer would have to pay. Either use your Twitch Prime, which you have for free if you have a if you have an Amazon Prime account, then you don't get any ads. That gets the ads to be removed because you're a subscriber, and it's free, completely free if you have Twitch Prime. I'll say it a few more times. But all I can do is increase or decrease the frequency of ads and the length of them. And right now I have them at there's like a slider. I have them at the very lowest amount, which is every hour a 30-second ad. Oh, it's okay, it's okay. Well, at least now if there is an ad, it should just put a message in chat saying there's a 30-second ad break, and I'll try not to explain anything too critical during that time. But anyways, so I know you guys wait. Okay. I thought I was seeing something. The ad I saw is when you started the view. Oh, it's the pre-roll ad. Yeah, so that's always gonna happen. Unfortunately. But at a certain point, it goes away. Can I make this even more big? Oh, I can. There we go. So I'm apparently receiving nothing. I don't know if I'm... Okay, so what I'm seeing here is a bunch of zeros because it doesn't actually have data. But this could be a good thing. Just kidding. This is not a good thing. What we need to do is initialize our command to at least have some value so we can see if it's ever getting kind of manipulated. So let's just do a value that's kind of easy, like A5. So what should happen is when we program it, you should see a bunch of A5s here instead of zeros. That would mean that it is sending out of my chip here. Data's coming out of it just fine. So we'll start with that. So we're gonna go ahead and make USART again. Oops. Just gonna make USART. And then we're going to STM flash program USART.elf again. Okay. If we receive, we aren't getting what we wanted. That's okay. Well, at least that tells us that this is something slightly off. It could be because we're already clearing this. So I'm going to hit the reset and just see if we ever get at least one A5. Okay, we're never getting at least one A5, and I think that's just the order of operations. 1 hex character equals 4 bits, 2 hex character equals 1 byte. Yes, that is correct. So let's do this. Let's just change the order of these two functions. Here. So here, this is the receive function. This is the send function. We're just gonna swap the order. And we're also going to comment out this. You know what? How about this? For now, we will comment out receiving. We just need to make sure we can send data. Make sure this function works still. Okay. Make USART. Flash it. Go to our waveform. Clear our terminal and start receiving. Okay, here we go. This is better. We need to make this display hex though. Right now it's displaying ASCII. Here is the settings for that. I remember changing it the other day. Oh, here we go. Number and hex. That actually might have been the problem. This should be number, not text. Okay, H is just there by default, but that just means X A5. Okay, so theoretically, we comment this back in. Data comes in. We wait a little bit. Actually, do we even need to wait? I don't even think we need to wait. I think we can just get rid of this wait. Let's try. Default to the 360p. Oh, what the heck? Yeah, that's a problem. Definitely want to increase the 720p. Alright, so that's sending a bunch of data. Let's go ahead and make it again and flash it again. Alright, we see it's sending zeros. We're gonna clean this. See if it ever sends an A5. It doesn't. When I hold it, nothing sends. When I let go of it, 0 sends. If I send one data, okay, nothing comes out. Just to make sure I'm hitting sends. The green is me pressing sends, but it's not echoing whatever. It's not changing the data here. So we gotta see what's going on here. So data buff gets passed into this function, which which we say, hey, we want to store the contents of this register into here. And then we want to turn off our receive. In fact, what I should do is go to the data sheet and finish that section I was reading, because maybe there's another step we are not doing. So we go to USART receiver, and we were here. All right, so we enabled this RE bit to actually read. FIFO when it's disabled, which it is. We check this bit to see if it's ready to receive data, which we do with the busy while loop. We can skip this section because we chose this option. We don't have interrupts enabled, so we can skip that. The error flags can be set to frame error noise. Okay, we can skip that. In multi-buffer communication mode, the RxNE flag is set after every byte reception. Alright, we're not in multi-buffer, we're in single buffer. Oops. When it's disabled, clearing the RxNE flag is done by performing a software read from USART RDR. The RxNE flag can also be cleared by programming this bit to 1. The RxNE flag must be cleared before the end of the reception of the next character to avoid an overrun error. Okay, this is where I show you guys a cool feature that the STM has. So we're going to stop reading that. The code's still running on our chip, but you can tell because it's blinking. We're going to open up a different app that lets us pipe into the chip directly and look at address values. So we go to the programmer. There's a free little tool. Super handy. And, well, first, can we make this larger? I'm going to guess no. I guess all these apps don't have that ability, which is super annoying. It's almost like I need a separate screen for looking at these small programs so that way they get blown up. But anyways, what we're gonna do is we're gonna connect to the chip, and this is memory right here. This is just the raw data stored inside of the chip. What we're gonna do is go to the actual registers, though, the same ones we've been manipulating, and go to the USART or a giant screen. Oh, trust me, I have a giant screen. The problem is the text is too small. The text is too small. It doesn't zoom in and out. You see? I need it to increase its text size. So, the RDR was the register that apparently has our data, but I don't actually see anything in it. But then again, I need to hit run. Okay, there's a few things I noticed right off the bat. One of them, this is empty. This shouldn't be empty. Especially if we pause. This should be changing ever so much, but it's not. Let's check our control register, because it looks like our control register is also off. Oh, wait, hold on. We're in the wrong USART. Okay, USART 2 is the one. My bad. All right, let's read a bunch. Read. We're trying to look at this changes at all, but it's not. It's 0. For those that you can't see, it is 0. CR enabled. There's a 1 for U enable, but there's a 0 for R enable. Does it ever change? Nope, not really. It stays as 0 the whole time. So if my loop was working, this would be toggling this bit right here, not the TX, but the RX would be toggling back and forth. The TX is toggling back and forth. But the RE is not. So why is that? That's what we have to figure out. Maybe there is another setting we need to configure before we can do that. FIFO mode, for those of you who don't know, FIFO means first in, first out. It is just a buffer for data that is coming in. You can store multiple packets of data. So that way, if you're sending and receiving data faster than you intend, it can be at least saved and have a little bit of latency. But it looks like these don't pop on unless we are actually using those, which I don't know if we want to by default, because I was able to send stuff out without using it. If TX can work without a FIFO, I would imagine you can do RX without a FIFO. But then again, if we go to this diagram, yeah, it looks like you can skip past it, because if you skip past it here at this one, surely they designed it the same way. Request to send, clear to send. Do we need to activate these pins? Hardware control mode. The following pins are required in hardware flow control mode. When driven high, signal blocks the data transmission at the end of the current transfer. When it is low, the signal indicates the USAR is ready to receive data. I wonder if there's something going on. I would have thought that would be handled by the hardware itself. You know, something I wouldn't have to do, but I'm looking here and it may need my input. Then again, these are the only... no, I don't think I do. I think this is done automatically. Because these are the only registers I have access to. You can tell this is COM controller. And it's the only one that talks to this bus. If you look at the RX, I mean, it's only ever connected to this receive register. Let's see if there's another register that's relevant. Control register, RX FT config, RX FT interrupt enable. These are for FIFO configuring how many slots you want in the FIFO. I'm defaulting to 1/8, meaning it can receive one, I guess. So it looks like it has at least one. Never mind, it's not actually skipping it. It's just storing one message and that's it. Because it's an 8 message sized FIFO. Threshold interrupt enabled. Nope, not that. Driver enable priority selection. Don't need to worry about these. Don't need to worry about that. DMA no. Overrun. SPID is used to disable the receive overrun detection. It is set when received data is not read before receiving new data. So over to previous content. This and then this is. Let's go see if this is set to anything. This is in CR1, CR3. We open up our STM program. We look at CR3. CR3 is 0 the whole time. Okay, so it's not being set, which would make sense because I never actually did anything in that register. Let's keep looking. RTS enable. That is ready to send. Interesting. So you do have some control over it. What happens if I don't add it? I wonder if I need to. If I do enable it, data is only requested when there's space in the receive buffer. The transmission of data is expected to cease after the current data has been transmitted. Clear to send is the opposite, but for transmitting, well, considering I never needed to use it to send out data and receive it on my waveform device here, I'm inclined to think that I don't need to use this. If the hardware flow control feature is not supported, this bit reserved and must be kept at reset value. Yeah, so we'll keep it at reset value. Half duplex. Half duplex mode is not selected. That's good. We want half duplex, or we don't want half duplex, meaning we can only send one way. We want to send both ways. Blob register, that's already been configured. Guard time prescaler. Wait, what's guard time? Guard time is for smart card mode. We're not using that. Receive timeout register. Oh, interesting. Oh, it's part of the smart card though. We're not looking for that. Oh, no, you have choice. Yeah, okay, you can do this if you don't do smart code. Wait, no, this is smart card. Maybe it's this one. Yeah, receive timeout length. So basically, if you want to set a flag if you haven't received a message in a certain amount of time, this is what will let you do that, which is handy. Handy for making things more safe, more responsive, and also resetting if things are going awry. Register. I wonder if this has anything to do with that. So this would force a clear. But the problem is it's already cleared. We saw it earlier. We saw it when we scanned that it was just 0 the whole time. So it can't be that. This is the threshold flag. Don't need to deal with the FIFOs. Oh, FIFO's full. This bit is set by hardware when the number of received data corresponds to RX FIFO size plus 1. So, I wonder if this turns on by itself. I'm gonna say it does. But the problem is, what register was this again? This is ISR. ISR is not seeing any activity on the RX stuff. It's only seeing activity on the TX. You can tell these two are set to 1 if you can't see. Yeah, that's a unfortunate situation. What's this? Acknowledge. This bit is set, reset by hardware when receive enable value is taken into account by the USART. This is if you have... wait, hold on. It can be used to verify USART is ready for reception before entering low power mode. Okay, I see. This is something we don't need for this situation, but if you were trying to get it to acknowledge that it's ready, that's a way to validate that it actually thinks it's ready. It's the acknowledgement. Mute mode, we don't need that. Send break flag. Oh, interesting that you can do that. That's kind of cool. I wouldn't have expected you to just be able to configure that. Character match flag. This is good too. If you're looking for a very specific byte value, let's say all your messages start with A5, you could have it sync up where this would look for A5 and trigger an interrupt if it saw that specific message. That is handy. Underrun, SSPI, don't need that. And the block flag, don't need that. Receive timeout. I feel like we read these before. When break, nope. Transmission complete. Oh, that's for TX. RX FIFO not empty. Yeah, it can be handy, but we don't need that right now. Overrun, nope. Noise detection. This bit is set by hardware when noise is detected on a received frame. which... Hold on. That was inside of the USAR alternate. That's just in the ISR. Okay, well, we already looked at ISR, and our ISR doesn't have those set, so nothing there. What about this alternate? Receiving knowledge. I think they're the same. If I'm not mistaken, yeah, these are the same. Interrupt flag clear. We don't need to clear any flags because we don't have interrupts enabled. Then you just have received data. And transmit data value contains a character to be transmitted. Well, kind of stuck at the moment. This thing on? It's on, yeah. Fortunately, even if it's number or text, it's not going out. And we have the same settings. We need to figure this out. It's a little bit hard to figure out, though. What's a good way to debug this? Because we already saw that this isn't changing at all. I think there is a mode I can use that lets me have a breakpoint. But I need to refresh my memory a little bit. There's a tool that is a part of my Visual Studio Code that should let me put a breakpoint. Also, our music has stopped. What do you guys think? Was the music loud, distracting? Should I keep it? Should I remove it? Should I turn it up, down? I'm just scrolling through a list here. None of them are going to be songs that are recognizable, probably. But this one, City Beats from Seoul. Very quiet. Maybe it'll come in louder. Like lo-fi. But anyways, it's this tool here. If we open up my Makefile, I think I not linked it, but I at least put it in written form. Yeah, Violin. Okay. Here we go. So let's open OCD. It can let us debug, but I kind of forgot. I think, well, first of all, I need to disconnect here. Because they'll both be pulling the same port. But it looks like what I need to do is kind of type this out by hand to at least get it to pop up. OCD, a little bit. I think I might, TBH. Hold on, why is it not auto completing? Open OCD, there we go. Open OCD. What are my flags? Flags are up here. So we need these. Copy, paste. Is that all I need? I think that's all I need. So enter that, which should open up a port. Oh, geez, I really don't remember this. Wish I wrote this down. So it opens up a port in one terminal that acts like a server. And, oh, how about this? I'll split screen it. Yeah, there we go. So this left one is a terminal that's acting as a server, and it will facilitate the communication. It is receiving and sending data from my computer to the board whenever it wants. And this right terminal is going to be, oh, interesting, my mouse disappears when I'm around it. right terminal is going to be my control interface. So what I need to do is, I think I run OpenOCD again. I give it the flags, and then I think I need to give it the program. Not mistaken. But I think I'd be more comfortable Googling it, if I'm being honest. I think that's the move here. So we're gonna put a new window here. I'm gonna look up Open OCD STM Flash. Actually, maybe we should do ChatGPT. I don't know. I mean, I've definitely gotten. Okay, hold on. This could be a clue. I've definitely done it before without ChatGPT. Just ChatGPT might be faster. GDB debugging. It's like something remote. Because if I run this, yeah, it's gonna fail because I'm already connected to that. So there's definitely more to that command. Maybe it's just OpenOCD. Oh, I think that's what it is. Is it ARM? ARM. Okay, ARM E by O. No. Link. We just gotta see. It's one of these, I think. But none of these look right, so it can't be that. Google search how to connect OpenOCD to STM32. Okay, we don't want a YouTube video. I definitely read something. Maybe it's this one? Oh, what the heck? Why is it so small? OpenOCD version. Yeah, we have the right version. He's just gonna connect it. This is downloading something. He's making something from scratch. That's fine. Oh, is it GDB? Oh, yeah, it's GDB. That's what it is. Try to do ARM GDB. Hold on. ARM GDB. GDB. Yeah, there it is. So we launch GDB. But I think I need to give it a command. Hackerman is in. Almost. Oh, that's cool. This is a way fancier user interface. What I just need is the command, though. I think it's GDB target center remote. The only difference is I'm pretty sure I have to pass in my file with it, so it knows what to do. So GDB. Oh wait, no, ARM GDB. Let's do -H for help. Oh gosh, that's so small. Okay, it is saying. Oh wow. Initial commands. Command file. We give it the file. Should be like a target thing. Where's --args? What's this page say? Anything? Maybe there wasn't. Oh wait. So we did this. Transport, select transport. That's funny. Does mine have some message like that? No. Just says it's connected. I'm pretty sure I had to put like port 3333 or something like that. I wish I could find an exact post. Here's source. No, that's the right. Oh, target or something like that. How to use, I should say GDB with STM32. That's what I really need. Okay. Oh, but this is using their IDE. Oh, this might tell me actually. Monitor reset hardware. Ooh, here we go. Port, dash P's port. Full length to the server. TCP port 2000. CP, directory containing STM programming 32 interface. That's for loading. Maybe it's not that. Maybe it's one of these other pages. I like the RD pilot. Oh, this looks promising. Okay, I'm pretty sure it's that. ARM GDB. Okay, so we're calling GDB, but the one compiled for ARM. Then we give it our file, which should be the examples. The project was called usart. No, oh, actually, I put them in the obj file. Obj usart.elf. Boom. All right, let's see. So this is just a license, and here we go. GDB is running. So now I need to run the command to actually connect to the target, which I think this page talks about. I can type help in GDB to figure out some commands. Okay, not quite what I was looking for. I'm gonna guess it's in. Could be under running. It could be under, yeah, help running. Let's try that. Okay. Continue. I don't see. Oh, wait. I think it was the one before that said attach. Maybe not. A bunch of start. Oh, target. Here we go. Target extended remote. This is it. Use a remote computer via serial line rather, using a GDB specific protocol. So if I go target extended remote, target, and I think we have to pass in the port. Where did it go? Okay, it's a space. Target extended. Oh, it doesn't. Oh, sweet. It does have autofill. And we can see on the left here, our port is 33333. Yeah, 4 3s. 3333. Boom. No such file. Okay. Okay. What else can we do? We need to target expanded remote. I mean, it's just, wait, what's the difference between remote extended remote? Use the remote via serial line. Use the remote via serial line using GTP. It's the same. It's the same. What if I just do target extended remote first? Okay, no such file. Or do I need the COM port? I mean, it could be that. I'm gonna look at the COM port off screen, just in case there's something I don't like showing. Okay, so it looks like COM7. That's what we're looking for. Remote debugging using COM7. I feel like that's not quite what I did last time. Oh, hold on. This showing anything? It's not. This is not. Timeout? Yeah, I don't think that was right. Okay, let's keep searching. Let's see what else they got. GDB. Restart. Is this just for GDB in general? I think it is. Oh no, open OCD in one terminal and starting GDB in a different terminal. GDB opens. What's next? Debugging watchdog events. Not quite seeing anything. Maybe I feel like I have a faint memory of using two different posts together to solve my problem. So we figured out how to get GDB going. Right, we got GDB. Oh, here we go. This is exactly what I'm talking about. Here it is. Target extended remote 33333. I need to put a colon. Target extended remote colon 3333. And then we should see activity on the left. There we go. That's perfect. Okay, we even see where we're stopped at.
All right, now we're in business. HackerMan is in.
Took a little bit longer than I thought, but we're in. All right. So if I press C, that means continue. And then, where was that? This one said to do what deposit? Probably just stop, I'd guess. Control C stops it. Okay. So we're basically at the same spot we were when we were using the STM tool. The difference is we can now pinpoint exact variables, which I don't know if we could have done in this tool. Thinking about it, because it's just showing registers of the chip itself here. Oops. And this one is just for programming. This one is for looking at device memory. If I knew the address, I could, figure that out, but it's not really. What's this one? None of these are going to open up unless I connect. Serial wire viewer, MCU core, option byte, secure program. Yeah, none of these are the same, which is fine. That's why there's other tools. So let's say I wanted to look at the contents of this variable here, data buff. What I can do is, I think, just type in like show data buff or something like that. Like show and then the name of your variable. Show. Oh, all right, I'll do help show maybe. Make this a little bit larger too. Okay. Continue. There's a lot we can show. Show value. Show user. Show trace. Show TCP. Show remote. By the way, this is what all your GUIs, your IDEs, this is what's going on in the background when you are doing your debugging in, let's say, ML Studios. Behind the scenes, those buttons are using these commands. Pretty phenomenal. It all starts from the command line, really. Some kind of interface. Yeah, I definitely have done this before. I think it's better if I just search it. GDB. Oops. GDB. GDB show variable value. Let's do that. Print value. Oh, it's print. That's right. I remember now. Sugoi. Very Sugoi. Okay, print. Print data buff. Symbol is not in the current context. Okay. Print. List. So list shows us where we're at, I believe. Ah. Okay. This is helpful. This is helpful because it shows us that we are in the sending function when we pause, so of course it's not going to show anything. Let's continue. Pause again. List. What if we do show our print data buff now? It should be 0. Yeah, it's 0. 0 and 0. Not much to it. So this function right here isn't actually doing anything. What we're gonna do instead though is we're gonna put a breakpoint inside of a receive function the very first time we run this, so that way we can see if it ever gets anything. Oh, I just realized it's not gonna get anything because we're not sending anything. Duh. Can we spam this tool to send stuff all the time? That's the question. Spy. Send and receive. That's kind of a bummer. I can't just automate this to send a bunch of times. Okay, well theoretically, right? If we go to not this function, theoretically, if we put a breakpoint like right here, no, right after the while, we should see, we should only get here after it's received something. Maybe this logic's off. That's always possible too, because it's 0 right now. Data register. Yeah, actually this might be the key to it all. I believe the datasheet said that only pops up. That only pops up when where did that go? To ISR? Here, 5. Just make sure. Yeah, 5. R, X, and E. Read data register not empty. It is 0 when data is not received. Data is not received. If data is not received, this is 0. Not 0 is 1. Oh, hold on. Now that doesn't make any sense. So let's say this was 1, meaning data was received. This turns to 1, which goes to 0, which means you exit it out. 0 to 1, it should stay here. The only way it can exit is if it actually got data. We're going to do a breakpoint. We have to do breakpoint at 196. So let me show you how you do that. I think it's like help breakpoint. Let's see what they got. Help, you can just do help B, and then you give it a spot. So if I want to do it in another file, break or B, what was that line? 193 inside of BSP. You start, or I think it goes like this. You put in the file name, you start 193. Okay, let's see what it said. No source file name. Oh. No, don't share that. We want to give it the actual file here. There we go. There's now allegedly a breakpoint at that point. So if we do restart. Okay, it's not restart. Program has been start from getting yes. Boom. Automatic stop. Automatic stop. If I know the address of this, interesting. They gave you the address of that. That's actually pretty chill. That's cool. They gave you the address of the variables you pass in the function too. That's really cool. So theoretically, if I do print data rx, misspelled it, data rx, we can see it's at this address, and this is the value in that address. Garbage. Literal garbage. It's a 30, no, it should be an 8-bit. It's interesting. Anyways. We can do, let's put another break. If we continue, we're just gonna keep halting here. Is that what's going on? How about we break clear? No, how do you do clean, clear? Clear clears breakpoints. Okay. We continue, then stop, continue, stop, continue, stop. Huh. Let's put a breakpoint at BSP usart.c right after the while loop. So 196. Oh, colon 96. No, not 16. Sorry, clear. 196. Okay, so if I see to continue, we're hitting this breakpoint. We shouldn't be. I now see the issue. We're not actually checking memory. This is a macro. This is just saying, hey, look at this value. One shifted 5 spots over. What we needed to do was... Oh wait, hold on. This is the perfect moment. This is the perfect moment to debut the drawing tablet. Maybe not the perfect moment, but a moment. Go to note. Okay. Can I hide these? Oops, not full screen. Jeez. Is there a way to hide the ribbon? I guess not. Oh well. See this? Hello world. Wait, wait, wait. Okay. Gotta get better at doing that. I was basically saying, hey, while 1 shifted over 5 spots, which gives you some number that's greater than 0. This is like 1 greater than 1 or less than 1. It's greater than 1. So no matter what, and then I take that number and then I logically OR it, which is now while 0, which means you're gonna pass the while no matter what every single time. What I need to do instead is say, go to this address, and then AND it with this 1 shifted 5 times. So that way I can actually say, hey, what is at this address at 1 shifted over 5 times? This address. Anyways. Silly me. Simple mistake. Took longer to fix though. So we're gonna go USART. We're gonna look in the ISR register and look at this variable. We're gonna say if there's a 1 here, this whole phrase becomes 1. If there's a 0 here, then we wait. And that's what they're gonna do. We're gonna wait. So now that we successfully did all that, we need to quit out of both of these. Yes. Okay. Quit out of this, and we're going to make USART again. But now it should work. So make STM flash program equal to USART.elf. All right, it programmed. It is halted by something though, because this is not blinking. This is solid snake. What's halting it? Oh, this is where things get crazy. I did not clear my breakpoint. I think it is halted right now, or you know what? This is what we want. This is actually good behavior. This means it's busy. It is waiting for me to send a message. A solid LED means that that busy while is actually stuck. So theoretically, if I send this, oh my gosh. Okay, I may not have been printing it out. But it definitely, it at least went through once. Let's reset it again. You see how it's stuck? Solid, no blinking. I'll slower this. It is stuck here at this line. I think though, let's clear this. It's not actually sending the data right, or saving the data right. Okay, this is fine. We can use this program now to speed this up, where we connect to it, we come into the registers, we're in USART 2, we read, we hit play, we read, and we see it's frozen right now. Oh, maybe it's not. Yeah, I don't think it is actually. You see, RE is a solid 1. It's never turning off. Spamming this to see if there's ever a moment it turns off. It's not happening. Wonder why. Wonder why. This would be toggling a bunch of times. Because this should be running. Oh, maybe this isn't clearing itself. Go to the ISR Oh yeah, this doesn't look like it's clearing itself. It's an idle. It's ISR? Yeah, it was ISR. Enabled. RE acknowledge. Bit 5. RX char. We're looking for this bit right here. RXNE. They call it FNE here. What if I go into this one? Is it also FNE? It's also FNE. Why is it FNE here? And bit 5 matches up. I'm not really sure why it's called that in this program, but it is getting cleared, but there's other stuff that's getting set instead. So if I reset the processor, reset the core, and then read again, is it any different? Oh, stopped. Ran out of music. Let's choose this playlist. Sure. On the go with the hack. Anyways, I just realized I put this in a hard to read spot. Well, it's not even easy to read to begin with because of the silly window. If I search RXNE, yeah, nothing for it. Doesn't exist. This program doesn't think that exists. It does, but it's over here. Got a different name. Why is it 0? I mean, if I'm not sending anything, I guess that makes sense why it's 0. So let me hit send. Oh, we got some data there. I'm spamming send right now. Where was that data? Oh, because I reset it. I reset it. I clear it. I send. No, didn't see anything there. How about this? What we can do is say if... No, actually, we should just do a data. We need to do a breakpoint. We need to do a breakpoint right here at 199. We have to do that. I think our other tool is going to be more helpful here. So, simply, let's just go up, start our server. Access failed because this STM program is holding it open, so let's disconnect. Okay. We're going to connect to the server again. Then we're going to start up our GB. Continue. I bet you... Oh, frick. Okay, we're good. Target. Remote. It's an extended remote, sorry. Extended remote, and then 3333 for the port. We want to put a breakpoint on line 199. Yeah, because then we can actually read DataRx. So, break on bsp-usort.c, line 199. Then we hit C to continue. We actually hit that breakpoint. Why did we hit the breakpoint? That doesn't make sense. That means we just skipped right over this. There's nothing even I'm sending. Maybe I didn't reset the chip. Yeah, maybe I needed a reset. Okay, yeah. I needed to reset, my bad. So it's stuck in a busy while, you can tell, because it's just solid light. So, come over here. We hit send. Now we got to our breakpoint. And this is where I go print data rx. Except I gotta spell it right. Okay. Data rx did not change. And you can see DataRx was passed in as a variable. Is passed in as a variable. This was the contents in the address. I meant to say pass in as an address. These are the contents. It's the same contents here on the line that I had a breakpoint on, which should be... Actually, no, I sent it at the line after. This should be updating it. It is not updating it. I need to figure out why. That is the magic. Who knew receiving would be more difficult than sending? I did. It is way less in control. More things get thrown out as well. Hit continue, what happens? And then it just permanently hits. It just permanently keeps going. That's interesting behavior. That means this is latching high somehow. It passes through once and then it's just permanently going through. I don't think I'm doing all the steps. I think this is me simply not doing all the steps. It turns to 1. It is cleared by reading from the USART register, which you would think this line right here. Oh my god, we did it again. We did it again. Oh shoot, we did it like 5 different times. The same problem why this wasn't working is the same reason why this isn't working. We need to actually get the data out of the address or out of the register. This is simply a macro. Yeah, this is simply a macro. Okay. We're never actually reading out of here. What I should have done is... can I connect to it? I don't think I can. Yeah, I don't think I can because I'm connected to it. Let's quit out of this. Yes. Can I connect to it now? Probably not. I need to drop this. Disconnect. Theoretically, if I go and check RDR is empty for some reason. Not sure why it's empty. That's a weird thing. Okay. We're gonna go ahead and ban this person. Let's see. Go ahead and deal with that person. That was easy. Let's just make this now. And flash it. Oh, it's not leaving it open. There we go. Okay, it's stuck. Let's send it a message. Also, let's turn on receive. Clear this. Send. Send again. Send again, send again, send again. I think that works. I think that works, and I took way too long to make it work. But we got more familiar with our debugging tools, so it's not terrible. But if I change this to... Oh, wait. It does not work. It does not work. I spoke too soon. We initialize this to be A5. This should be 5A. Okay, so it's not actually taking the data and storing it in the right spot. What it is doing though is clearing. Where'd it go? when I hit send, it is getting past this stage without a doubt. It is just not transferring the data into the read register, the receive register. That's something we have to fix. So I think I'll connect this again. Read this. Yeah. Nothing new here. Get rid of these. We're gonna look at the data sheet one more time. Receiver. This is just talking about clocks. The start bit is confirmed. RX any flag set. Interrupt generated by RX any interrupt enable 1. Or RX F any enable flag set. An interrupt generated if RX not enabled. Hold on, is there a straight up difference? What if I go to my code and try to just access that macro? Is that a thing? USART, ISR, is there really one with a different name? Oh, there is. That one's an ISR. This is one shifted over 5. This is one shifted over. Oh, this is the same. This is the same. It's just another name. Okay. Because maybe it writes to the same spot if you have FIFO on. Okay, well, let's go back to this. The start bit is validated by the any noise flag, not enable noise flag, is set if for samples 2 and 3. Where are we at? It's gotta be over here. Samples for both samplings, 2 out of 3 sample bits are at 0. So this is just talking about the start bit being validated. We don't need that. Configured CR, configured baud rate, configured stop bits, enabled USART, enabled DMA, which, well, we did do that, but we don't need to because we're not using that mode. RE, this enables receiver watch, which begins searching for a start bit when it is received. RXNE bit is set to indicate that the content of the shift register is transferred to RDR. In other words, data has been received and can be read. As well as their associated error flags. Maybe I should check if there's error flags. That could be something. We see RE acknowledge. We see TC. We also see idle. Maybe I'm not clearing stuff. So if I try to send something again, is it stuck? Is it oh, we already ran out of music? That doesn't make sense. Okay, well, let's just click another playlist. Maybe what's happening is... Wait, how's this 0? Hello? How does it become 0? Become 0 when I reset it? Is that what's going on? Oh yeah, it is. Okay, let's put it at 0 again. And then we're gonna read. Oh no, it's still here. It's still here. And that could be because of this function. No, wait, you go through RX first. What could this be? Anyone know? The receive character. Oh, you know what? Maybe I'm not setting it all the way. Maybe TC gets set up when you initialize. That could be it too. Where's our initialize function? Here it is. Hold some of this. We enable this bit. This is for timers, for clocks. This is for pin assignments. This is for number of bits. This is for number of stop bits. This is for baud rate. I should double check to make sure I'm passing in the right numbers here for those. 8 0 0. Actually, no, we don't need to check it because we already got messages. Yeah, we were sending out messages, so that's definitely fine. Welcome to Embedded Programming, where you are lost because you can't figure out where it's going. Hey, Sean. How's it going? How's the music sound on YouTube? None of these are TC. That's TDR. This is TE. You left YouTube for here. Now you're on Twitch. Welcome. Welcome, Sean. If you go to YouTube, you get the 1080p stream, though. At least I think. Maybe this isn't getting cleared. Or maybe it's 1 by default. I could check that, I guess. If I go to... I go to... Oh, shoot. I should say which one. ISR. ISR. Not alternate though. Regular ISR. TC. Okay. There is a reset value. C. C would be these 4 bits. A is 1010. C is 2 more than that, which would be TC. Okay, so these are 1 by default. So maybe I'm not really seeing anything different. This just looks normal. But idle should not be on. If it's D, that'd be, oh wait. F is all 4 on, E is this one on, D is, oh, okay. Yeah, no, it should be off. Why is idle on? Bit 4. Idle line detected. This bit is set by hardware when idle line is detected. An interrupt is generated if idle 1 in this register is cleared by writing 1. What is idle line? Idle bit is not set again until this bit has been set. Idle, I guess, just means idle. Cleared by software by writing 1 to this register. Maybe I need to be clearing the idle line. Then again, we're never actually getting a message. Oh. Nothing too crazy. So, this is where we save some time and whip out ChatGPT really quick to see what they do for a quick UART driver. Because I bet you they have a really fast answer. Hello. Let's see. Can you write a UART receive driver using using only CMIS functions for the STM32U5757 or no 575. Okay, they're doing it with the interrupts. Could you write it without? Could you write it without interrupts? It's gonna say absolutely. Oh, certainly. My bad. Okay, init receive byte. Do that. Do that. In their case, they're returning it, but that's fine. How are they even doing this? RX index? Increment the buffer index and wrap it around if necessary. What is ChatGPT doing here? Where's this variable even coming from? It's not even initialized. Oh, it's initialized 0 up here. There's a buffer size of 100. So for every byte you receive, you put in a buffer and you append 1 to it modularly. Modularly? I don't know if that's the right way to say it, but anyways, it's just receiving data. Okay, yeah. But I'm not doing anything different. I mean, if anything, this is different. And maybe that's part of the issue. I'm keeping the receiver just on. So we can try and take the receiver, turn it on in the initialization. But I don't really think that's gonna change anything, if I'm being honest. Okay, so they're saying don't turn off the receive hardware, even though I feel like you could save so much power by turning it on and off. They're saying just keep it on. Maybe it's not enough time. Maybe you're not giving it enough time to settle down. No? Okay. Well, anyways. We're gonna yank this. We're also gonna comment this. And we're gonna put it in our initialization up here, right here. I'm curious if we do the same for here. Enable TX bit before sending buffer. I guess maybe it just doesn't work that same way on the TX. But alright. We made it. Alright. So we're going to go ahead and make USART again. Also going to clear this, and we're going to send over our program, which is being held open by this. So we're going to need to send it again. And then we're going to just see what happens. Clear. Send. F5. F5 is different. Let's send again. F5. So, what are we doing? How are we getting two messages? Really, what I'd want it to do is overwrite what's in this value. That's kind of interesting. I'm kind of not sure what's going on there. So we get some variable, we write in it, then we invert it, which the inverse of 5 should not be 5, it should be A. It should be 5A. But instead it's somehow taking A5 making it F5. Oh. Okay. I think I could see where it might be getting messed up. It's somehow shifting. Well, that doesn't make sense. This is just a knot. Unless you... Hold on. 5F. Unless you're storing your memory in a different region than you thought. In a different order. The endianness. Maybe the endianness is off. This is reading 9 bits. And when I apply this, it's removing a bit. Hold on, let's see what... Oops. Open too many things. So A5 is this. If you knot it, you get FF. I'm trying to think if there's a way that I was maybe capturing the upper bit. That doesn't make sense. It's somehow capturing the wrong bits. Let me check in this data sheet to see how the data is laid out in that register. Okay, that's what I thought. One more thing to check. If we set the configuration for a data length of 8, 987, we have it set for 8. It can only be written when USART is disabled. USART is disabled. It's really a combination of a couple things, maybe. A combination of not knowing why I'm sending it twice and why it's F5. I think I need to figure out why it's sending it twice first. So the program sits at RxChart. It receives a value, puts it in data buff. Data buff gets inverted. And then overwritten, even. Then you pass the address into txchar. Txchar, wherever it's at, txchar up here, enable tx bit. It waits until it's ready. It writes the character. Waits till it's done. And then it clears transmission complete flag. And disables the TX bit. And returns back to the main. Loops back to the top, toggles the LED, comes back to here. Is there ever a case where that would just run on its own? I don't think so, because it's stopping. You can see the LED, it's frozen. So it is stopping. It's only going through once. Where's the freaking program? There we go. Nope. Wait for it. Send. Pretty consistent too. Looking at a bunch of times, it's always the same. If I made this 0, would that change anything? Restart. Program it. Send again. That's interesting. Oh, wait a second. What if I change this to be 1-1? Okay. I think we have a clue. I think it's working. But we're getting an extra byte. Why? Because I put it to 0, we get FF. If I put it to 1-1, we should get EE. You know, if I put it to FF, we should get 0, which we do. But we're getting this FE consistently. What is a new line character's value in hex? I think it's 0. I can't beat that. Let's go to ASCII table. ASCII table. See if there's anything that FE corresponds to. F5 rather. F5, nope. Nothing. I mean, that's a pretty high number, so that makes sense. Nothing standard. Where's this F5 coming from, though? That's bizarre. 5. Txchar. Txchar takes 2 variables. That's our Xchar. Txchar takes 2 variables. Okay, that matches up. Data char. I think we need to look more in this function to see what it might be doing. Yeah, let's do like a step-by-step to this function. So we're gonna go back to using our command line tool. Where we open OCD. Then we open our debugger thing, GDB. Okay. Target, remote, or extended remote. And we'll put a break at 132, I guess. Yeah. Break, BSP, usart, yeah, usart.c132. Breakpoint there, hit R to reset, yes. Okay. So we need to trigger it initially by, let's wait for him, sending. Clean this. Send. We hit a breakpoint. We haven't sent anything out. I think S is the step. Okay. We get to the next line. While. We're waiting here. Okay. Step. Actually, can I do a print and then the name of that? Usart ISR. I wonder if I print out this exact line, Usart-ISR and Usart-ISR TXE, what would happen? Interesting. Oh, I need to say print. No symbol. Okay. What is this? 7? 1 shifted over to 7. Oh, I bet you this is like printing 2 different variables. Yeah, because if I do usart-cr1. Oh. No, it does end it. Okay, hold on. 1 shifted over 7 times. 1. Shifted over once. No, that's not how it works. Can I do this? 128. 120. Does that sound right? Calculator. 1 left shifted. Where the heck is the... Oh. No, wait. Yeah, we're... Oh, it's right up here. Well, 1 shifted 7 times. 128. Okay. If I do 6, if I do 5, if I do 4, 3. Oh, okay. It's actually telling me. This is actually huge. This is telling me what the value is at this register. It's a lot less straightforward as the SDM tool, but I can still use it. So if I do print $3, it's gonna show me what was here. That's fine. Anyways, so it's 1 right now. If this is 1, that means this goes to 0, which then means it skips the next line. So we're gonna do that. Step. Okay, we're now here. Let's go ahead and print data tx. It's empty. Data tx is empty. Why is it empty? Okay. We're gonna step 1 more time, but we're gonna check this register to see what's in it. We're gonna go print usart tdr 0. Why is it 0? We're gonna step some more. ICR. Clean up bits after sending data. Apparently I already sent it out. Here it is. It's 0 because that's the actual value it's supposed to be. I should have chose a different number, like FA, I guess. That threw me off, but 0 is the intended value, funny enough. Okay. We're gonna step again. Put this over here for a second here. Step again. Then we return out. Step again. Step again. Step help. I want to pass over this help step. Can I step over? Help step. Step. I. Step by means step n times. Okay, how about this? Help stepping. Specify single-stepping behavior at a trace point. Normally followed by one or more clicks. That's not what I want. Okay, I guess we'll just have to do it normally. Still. So step. Okay, so we toggled it. We do this for loop. It's looping, it's looping, it's looping. Come on. It's looping a bunch of times. Looping through this. In fact, I should probably just remove this. In the next build, I will. I guess it's just taking too long. Who knows how long that would take. Okay, I didn't actually send anything new. So... No, I'm not closing the receiver anymore. I was thinking, what if I was shutting it down? But I'm not. Data TX. Data TX has some random numbers in it. Right? If I do print data TX, or yeah. Look at that. It has some whack numbers. Maybe because this is an address. What if I do print data TX? Oh. It has the letter O, and it has this number 245. What's 245 in hex? F5. It literally has the value F5 in it. But what from? I'm not sure. We need to recompile this. Yeah, we need to recompile this. I don't know. Yes. Break that. We're gonna close this. We're going to do that. Make it, flash it, open the server up again. Do our same little debugging methods. Actually, I know for a fact I can do this. If I do, hold on, let me just try real quick. I'm pretty sure I can make this command. Do target extended remote :333. Listening on port. Oh, that didn't work. Target extended remote. Oh, I know. I need to do -C maybe. Exit -C. That didn't do anything. Oh no. That's for GDB. That's why. I'm looking at the wrong thing, Lamail. No, that's not what I want. Exit. Let's do just target. Screw it. Let's just see how target works. Oops. Delete 3. That work? Nah, it doesn't work. Oh well. Exit. It's worth the adventure a little bit. Okay. target. Extended remote. 3333. Breakpoint's still there. Nice. Restart. Okay. Started it. So we're gonna clear this. So we're gonna type in. Let's just do CC or AA. Do AA. So we send. Oh, it doesn't have any breakpoints, does it? It doesn't have any breakpoints, but still doing the F5. Okay. Pause it. Let's do a break. Not buff. Where are you just doing the regular? Takes chart. Break. USART TX chart. Can I do this? Breakpoint at this. Oh, interesting. I can just put the type of the function. That's cool. Oh, that's nice. Okay. So we had a breakpoint at the function name. We're at C1. We're going to step through this one. We'll step through this one. We're going to see what the data it got was. It should be the inverse. So 5.5 should be 5.5. Print dereference data TX. A5. A5 has an extra 1. I'm guessing. Huh. Well, that doesn't make sense. 8.5? What would be 8.5? 8.5 is 5 would be these two, just like this one is. Where is it getting 8.5? I don't know. If we step one more and we said print USART arrow TDR 85. Oh, I think I see the issue. 85 is decimal. Okay, never mind. 85 is decimal for hex 55. So we're gonna step. This is good. This is good. Step again. We continue till we come back. Oh, I went too far. I went too far. Yeah, I need to redo that, but I do print dereference data TX. Yeah, it's back to that again. Okay, so we're gonna do restart, yes. To trigger it, another send. Okay. $85, okay. So we're gonna step, so we're out of this function. GPIO. Hit the receive again. So allegedly, this is staying at the receive. Oh. Never mind. I was gonna say, it looks like there's maybe being appended an ending to what it sends out. But even that I don't think is true. Just messing with sticks. Looking for here. I want to see what's inside of this ISR at that variable. It's TX, we gotta go to RX. RX. 1 shifted over 5 times, okay. So print usart SR and 1 shifted over 5 times. 32, which means 1. So this is 1, which means this is 0. This never got reset. If I say print usart RDR, oh wait, not RDR, sorry, usart pointed over to RDR. It's 10 decimal, which is A. What's the inverse of A? Not. F5. A. What did we send over to it? Was it AA? It's sending an extra A. But then again, it's let me see what these values are in ASCII. I wonder if carriage return was 10 in ASCII. Do I have it? ASCII table. New line. Is this putting a new line? Carriage return would be a new line, no? What happens if we clear all breaks? Clear break. Also, our music stopped. Next. What about this one? This one looks fun. Ocean themes. Help clear. I just want to clear all.
Do you miss me at all? Do you think about the things we used to do? No,
Clear
you
1.
couldn't stand tall.
Clear 2. Is that a particular
So
line?
why didn't you
Ay, ay, ay. Not feeling
So
this.
many years has gone by.
Oh, John Hill has his own. That's cool. Four? It's wherever I put a breakpoint. I guess it would have been list break. I don't know. Help break? Anything? Yep, we're good. You gonna dip out? Okay, Johnny. I will talk to you later. Have a good night. Thanks for coming in. Keeping me company. So yeah, if I do exit, yes. Go here, back into it. That should clear the breakpoints. And then do targets, remote, extended, remote, 333. Continue. Just go on and on and on. Oh, interesting. It's not receiving anything now. Canicio. Very funny. second account? Or is this the same one? Is this the same account? Okay, for some reason I never read your full name. That's funny. I thought it was just your regular name. Why is this not working? As soon as I got rid of the line feed or the carriage return, oh, this is just frozen for some reason. I think I needed to reset it. Hopefully. Maybe. Bruh. Oh. This looks promising. None. Send. Oh my gosh, this whole time had nothing to do with my code. It had nothing to do with my code at all. In fact, it's working as it should. It's because I had this carriage return setting turned on when I was using TX. It was adding an extra byte to every time I send. That's what F2, or I guess it's adding line feed, which is F5. Oh my gosh. Oh my goodness. That's why you always check your settings. Because you never know. There could be a hidden setting just turned on by default. And you could waste however long I did. Well, that's part of programming, right? Sometimes you come into stupid mistakes like that. That's not even part of the code. But it's so crucial that you just memorize the lesson you learn from it. So every failure is a learning step. That's funny. I now know this program does that. This is my first time trying you out on it. Now, I won't make that mistake again. Okay. So our function works. That's cool. In fact, I didn't even need to do this disable hardware stuff. So we're gonna get rid of that. We're gonna delete these white space lines. We're also gonna get rid of this up here. Delete too much, okay. So, what I really want to try out is this sending with the buffer of data. Guys, I'm not sure if I need to be looping through it or if it just works on its own. But before we do that, I want to make sure that I put a commit, because this is now working code. Oh, how do I, is there a hotkey to switch between these two? I don't know if there is. Anyways, we're going to do git add all. Actually, let me see. Can I remove? Yeah, let's clean this up just a tad bit. And change the comment. Toggle LED and send the inverse of the received byte. Okay. Okay. Well, I guess we can clean this. So we're gonna do git add all for all file changes. We're gonna do git commit -s to sign it, then do a message saying created rxchar function and validated example. Start example. Okay, and then this is where I take this and move this over here. Okay, signed it, and then we push to origin not main, but dev UART. We want to put it on our development branch. So now we have these changes we made. It is saved on GitHub. All right, back to it. Funny stuff, I guess. Let's first test out our TX buff without the RxChar involved. So we're gonna go TX buff, and this is where we give it a data length. We're gonna say 5. We're gonna create this to be an address. We're gonna make it an array with the values 0. Let's just do 0, 1, 2, 3, 4. Okay, easy enough. I wonder if that's gonna compile. Make start. Okay. Didn't like that as an array. So instead what we can do is this. Reallocate the length. Do this again. We won't get a complaint because, oh, we will get a complaint. Let's go to that ChatGPT example they had, because they did something similar. They initialized the buffer first, and then they wrote to it one by one. Would you write a TX? What is it? They call it a receive byte send byte function that takes a series of bytes. See what they got here. Send bytes, size of, and then the actual array. Oh yeah, so I did the same. This is no different. This is the same. I passed in a pointer U8 into this. Oh, but they just gave it, they didn't need the address. It's already an address. That's where the difference lies. Okay, my bad. Now we shouldn't get that same error. Yeah, we don't. Okay, cool. Let's load the code and see what happens. So we are getting a bunch of data, and if we were to look at it, shouldn't have to do any clearing. Let's do decimal. Okay, we're getting, what was that, five values consistently, but they're not quite what I'm looking for. We're getting 0, 4, 2, 16, and what if I did text? 0 doesn't really make sense, so we won't be doing it by text. Decimal. 4 to 16, 19, 144. 0. Yeah, the hex values don't really look familiar either. 4, 8, 13, 90. Like these are nowhere near that. So this is where we go into our function now and see where we might be differing. And in fact, oh, they did loop. They did loop. Okay, so we pass it Maybe this is it. Maybe I don't need to be clearing this every single time. Maybe I don't need to be setting this every single time either. Let's try that. ChatGPT suggests we don't. Let's see how that works. What we should do is just take all of these and have them happen on the same line. Make that. Insert some more here and paste that into there. X and RX. Let's say these. SART is an acronym. Let's capitalize it. Oh gosh. Yes. So I have to go through all this. SART. Refix the capitalization on these. SART. X. Oops. SART. Okay. So they don't actually... Oh no, they do. They wait twice. Oh, am I waiting too many times? I think I am. Wait, no, that should still be the same, no? Oh. Guess you don't need to. They're saying you only need to toggle that on when you're completely done. And then this TCCF flag, I believe that clears, but they're not even using it. So let's comment this out just to see how it reacts when it's commented out. Okay, I think that's essentially the equivalent of what ChatGPT wants. Oh wait, no, this needs to go too. So we already enabled it up here. Yeah, it's already enabled. Okay. We're gonna do make SART. Then we're going to flash it. And then we're gonna try sending stuff again. Actually, yeah, receive. Stop. Okay, it's a problem. The data's just corrupted. Why is it corrupted? Figure out why that's getting corrupted. Maybe it has to do with how we're initializing it. I mean, what we can do is try and see what it actually thinks by putting a breakpoint and seeing the variable. That's one way of doing it. So if I go ahead and go to, here we go, where is it at? We open up our server again. How do I toggle between the two, I wonder? There has to be some kind of shortcut for that, but oh well. Go up here. Usual song and dance. Okay. Reset it. Yes. And we want to put a. Do we just want to put breakpoint? Honestly, we could just say continue. Oh, it's running already. We can just control it, and then be like, hey. Oh, but the first value is 0. It's not ideal. Oh, it's kind of glitched out right now. Alright. Where are we at? We're in TX? Can you... Oh, okay, this is fine. So if we go list, or no, print data TX, what we can do is... I should have swapped where these terminals were. Thinking about it. There we go. Yeah, because it's like on the left side of the screen is where I'm doing most of the typing. The right is just like the server. Okay, anyways, print tx data tx. What am I trying to do again? Oh yeah. We want to look at data tx, the contents of data tx actually, data tx 0. So if we do this plus 4. If we put brackets around it. 4 plus 1, 1, 2, 3. If I do 5, it should be garbage. Okay, yeah. It is garbage. So those data is going in fine. 1, 2, 3, 4. It's being passed in. To here. What line we're at right now? We're at 171. We're here. Wait until transition is complete. Maybe this function's off. This could be the problem. That is the problem. Yeah, this is definitely the problem. Okay. This is taking 9 bytes, an 8-byte value, and adding a 9 bytes, meaning it's appending a 1 to the front of it and storing it here. We don't need that. In fact, we can just remove this completely. We can still do this. I feel like the notation of this will work too. I could be wrong, but I feel like this notation should work as well. Which would be super... not super, but more readable than it actually was with the other situation. And then let's just quit out of this and recompile. So make usart, make stm flash program usart program equal to usart.elf. I'm just holding it open. This is holding it open. Okay. Now I think it should work. We clean this up. Receive. We hit stop. It doesn't work. I thought it did, but it doesn't. Okay, so this is not actually changing much. Oh, I think I can just do data count. I don't need to do what I'm doing here with the size. I can just do data count. Yeah, that's all I have to do. That's pretty easy fix. Okay. Clean this up again. Receive. Stop. There we go. 0 through 4. So this function now works. You give it a data length, which in fact we'll make this 32 to even maximize it. 32. In the H file, we'll also make that a 32. You can find it. 32. Place with the 3 inserts to the right of it a 2. Cool. Alright. That's fun. Let's commit that. Git add all. Git commit. -s -m. Tested. Let's see. Validated. Use sarts txbuff in example. Okay. Okay. Push origin dev uart. Cool. Now what we gotta do is make it so we populate that buffer with what we sent it. So what's a good way to do this? Go to our main. We have to make a function actually. We need to make a function that's more like this, let's say. Yank. Oh, no. Control Z. Control Z. V down a few lines. Go to the end of the line. Yank. Go to the bottom of the file. Open up a paste this once, but rename it RX. Rename it RX. Rename it RX. And rename this to incoming data buffer. Name this to RX. Size. You wouldn't know the size, would you? Oh. This could be different. Do I want to put logic that detects its size? I think that would be helpful. Yeah, size of incoming data buffer. Incoming. Okay. This is the R. And then we'll come over here and paste a similar thing. Get to it. Oh, actually, no. This is what we learned last time. We can put this. Oh, we also learned that we should be capitalizing this, because we want to capitalize acronyms. Use SART. Place. No, wait. Insert RX. This one. There's probably a vim command that lets you Make the selected content uppercase, lowercase. I'm pretty sure there is. I need to learn that. Anyways, 142 go to B150 go to. Oh, that's pretty cool. That's handy. That's way faster than what I was doing. Okay, then this is where we go to the bottom of the page. And you paste A1 here. We can go ahead and put these here right now. Not sure what happened there. Whoa, that's cool. I didn't even know that was going on. It shows me a preview of what function I'm in. I like that. That's cool. Okay. Let's delete that last thing. This is where we need to. Daylight's fine. RX, that's fine. Usart, that's fine. Okay. What if we just called this function a bunch of times, but changed it to return? Like the ChatGPT kind of brought up a good point. We could make this function just return. That would save some time, because it is just a fundamental thing. I mean, what would I even check? Oh, if there's errors. Yeah, actually, okay, I do. I think I want to keep it out for now. Alright. So for USART, we need to do a lot of the same steps. We need to wait. Right. We need to wait until all the data gets put into the RDR. And then with that data, we put in the data RX. But the problem is I don't know. How would you know it's done? If you're doing a bunch of data, there has to be a different indicator. And I bet you this ChatGPT solved that for us. Receive a byte. This one's just always receiving a byte. Maybe that's the key. But that's a busy while. Yeah, maybe that's just how it works. Is there any way to draw this out? My tablet turned on. Cool. Okay. Oops. Wrong one. We have a while loop. We got some data that's coming in. That gets put into a buffer. This. Trying to think of what I've seen from my own experience. I feel like having byte, RX byte is fine. Where you just receive it a bunch of times. You call this. But I like this better in an interrupt sense. Or an interrupt or an event based system. If you're receiving one byte at a time, that's a lot more doable. But if you're Receiving a whole packet. Is there a better way to do it? 'Cause this would work, especially in the interrupt sense. And that might be the most efficient too. You have a packet. You have a packet of data. Shoot. How do I put this back to how it was? If I start drawing again, it's gonna be way bigger. Ugh, oh well. We have a packet of data. We somehow need to have some way of knowing when to stop out of that function. Because originally I was gonna say, you know, listen until you see the end. But how do you know when the end is? Until, gosh darn it, I can't spell. Until the end of packet. So until the end of the packet, you want it to read a byte. Read a byte of data. That's essentially it. That's all I ever wanted to do. I think it's a little bit harder when you have data that is uncapped. Because if your data is uncapped, the user could just send, I don't know, just receive, and it just could really freeze a program. What if you, what, damn, this pen is like totally jacking up the focus, the autofocus. Anyways, I think one byte at a time makes the most sense. Yeah, so we'll just keep it at that. I think that's what we'll have to do. Receive char. RX buffer. You just don't know how large your data size is gonna be. So this function probably needs to exist in a for loop outside of the BSP. And if I can think of a better way to do it, then I will do it, but I don't think I need to have a better way. I think this is fine. What I do need, though, is a little bit of a break. So I will be right back. And Okay. I have returned. And I think what we should do is make our example do what the ChatGPT example did. So, except we're not going to toggle it anymore. We're just going to fill it up, I guess. You know, do pretty much the same thing they were doing. We create this arbitrary data buffer. It's like 100 in length. And what we'll do is receive it. Right, receive a data buffer. But what we're going to be doing instead is sending just the character. We're going to do the character function instead. So this one will be send the address of a particular number. Data index, I guess. Remove this and replace this with camel case instead of, oops, not quite what I meant. Replace this with a capital B. Insert the address here. Place the capital B. Meanwhile, this data index, oops, view int 8, yeah, 8 still works because it's 100. Data index. How do you want to do this? I want to receive a bunch and then send that. I wonder if I can do it. What if I do this, where it's like it receives a string at a time? I could do this, where it's like, okay, while, oh no, I say do this, do this function down here. Pasta, right? Do this function while data buff while data index is not equal this, which is a null terminator. Okay. And then, oh wait, no, we're fine. Instead of data index, we're gonna replace this with data count. Oops. Count. We're also gonna initialize this to 0. But not up here. We're gonna do this. Actually, let me put this here. We want data count to be equal to 0. At the beginning of every loop. Data count. Data buff can be 100 up there, but it's 0. We want it to be count. count. We're going to take a byte. We're going to store it in this array at this spot. And we're going to repeat that and and then we're going to increment data count by 1. Actually, I think we should do that up here. Data count, I suppose. Because the first time you enter it, it's going to be off. So I think we just do data count the first time you try it, and then you increment. Or maybe... Hold on, we can do some post incrementing maybe? Yeah, I think we do post incrementing. Right? So what this means is we're going to try and write to data buffer at this index. We write to it, then we check the conditions saying, hey, while take the value, increment by 1. I actually don't think this is gonna do just quite. I mean, it might. I feel like if you do post-processing on it, ideally, what I want it to do is compare, then increment, so that way you're in the next loop. But even then, if you exit the loop, that's not ideal either. So I think we do this where we increment it after we assign it, and then we just check -1. Yeah. So if it's 0, up here. Let's see. It's just weird once you get to the 0 case. Like, let's say you get to 100, and you get to 99. You get to 100. You're saying, okay, 100. Let's also say this. Hashtag define buff size. We're gonna do 100. Just change it to this. Buff size. Alright. Let's say it's 5. Or 10. Let's say it's 10. Your buffer size is 10. You can only take 10 bytes. We want to have some condition where you're incrementing this only if you get to a good spot. If buff size, if data count, if data count is less than or equal to buff size, actually just less than. Well, no, if it's, yeah, if it's just less than. If it's less than the buffer size, which is 100, so 99, you can enter this. As soon as you hit 100, you set data count to 0, and that's when this is whack. I just need to see what the last byte was. maybe I just start this at -1. Is that the play? Or maybe I do data count -1 here. But data count plus gets incremented here. Data count -1. So really, I just need to do this. So if data count is less than buffer size, which is 100, so then we go, okay, 99 or 9. 9 is less than 10, so 9 is now 10. 10 minus 1 is 9. So you're trying to see if the last one is a null terminator, which now that I think about it, is it this? I feel like it's backslash. Don't we have the ASCII table up? ASCII table. Null terminator C. Just backslash C? I'm pretty sure it is. Yeah, backslash C. Send, received, buffer, toggle, LED. Receive string and buffer until null terminator is seen. And data count is less than buff size. So it's saying continue this, try this until you get the null terminator and your data count is less than this. Okay. Oh yeah, I should say if it's less than that, try this. Else data count is equal to 0. Oh, it's equal to 1. Huh. Well, hold on. Now this is whack. Data count goes in at 0. It immediately gets set to 1. We want to check if this is this one. Will this ever be 0 ever? Shouldn't be. If it's 10, so that'd be 9. If it's 9, then it becomes 10. Which that would fit. My question is, yeah, okay, this just works for the unsigned bit. But anyways, yeah. So then I come over here and be like, okay, I want to use tx buff. I send the data buff. I also send data length, which is data count. size of data count. And a factory can make this a 32, I guess. 32. All right, I believe this would work. Check if data count is within buffer length. Loop only when not. Loop until. Oh, I already said that. Oops. Receive bytes. Restore bytes in buffer until. Receive bytes in buffer until null terminal is seen. Or end a buffer. Or end a buffer. Or hit maximum size of size. Okay. So yeah, I wonder if this will work and if I break it or not. Make USART. Make STM flash. USART. Nope. Program equal to USART.elf. It's 10 right now in terms of my data size. So let's go ahead and wipe this. We'll do text. I'll do test. I'll do send. We'll do send. We got something. Test. Test. And then sum of test. Let's do text. We need to clear this. Let me set this as well. Clear. Send. 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 Test. 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 Oh, okay. So it's not exiting when we're not getting a null terminator. Maybe because I'm not putting the carriage return on it. Send and send. Okay, that's it. Set it again. Be that, yeah. And not quite. Okay. I go to ASCII here. ASCII data. Null terminator is just 0. Yeah, I mean, I guess that's just 0. So if I put a 0 at the end of this. There you go. Testing. Send. There we go. Testing. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Send. Let's try 0 now. Another 0. Yeah, it caps out. Yeah, I thought it broke for a second because it was... Oh, it won't even take it. Oh, when that happened, they didn't know what to do. It crashed. Okay. Interesting. So that crashes it. Not too sure why it's crashing. We're gonna bring it down to 1 again. Can't do anything. Do an easier number. 2, 3. And as I add 4, something like that. Oh, I think data count might be off. Yeah, I'm pretty sure data count's off. Maybe my function's off too. Data length, you pass it in. It's data length. Less than data length though. Okay, never mind. So let's say it's 4. In the last case where it hits the buffer size, which is 4, it says, okay, alright sir, you got 4. You pass 4 into here. Because there's only 3 here, 3 here. 3 here, actually. Right now, you hit 4. Oh, hold on. Your data comes in. Starts at 0. Comes in, it becomes 1. Loops back around, it comes 3. Comes 4. And 4 is no longer less than this, so it'll never become 1 again. Okay. Yeah, this should be less than 1. Yeah, that's all. It's only showing 1 or 4 now. 1, send, 1, 2, send, 1, 2, send, 1, 2, 3, sending. It should be sending. 1, 2, 3, 4. 5 or 5, 6, 7. I think I see what's happening. Depending the terminal there. So realistically, I can only send 3. Maybe what I should do is this data buffer, but -1. This is the same thing, I bet, huh? So you have 10. +1? Hold on. So it's like, okay, you get 4. 4. Yo, what's up, Jacob? You get 4 here. Just making some RX. Actually, we already made our RX function. We're making some UART functions, but I'm just making an example for it. I'm gonna I put examples with all of my library functions, so that way I have basically a sandbox to make sure my functions work. But anyways, how are you doing? Data buff. That is, yeah, I wish I was the one who came up with it, but in reality I just looked at STM and every other board support package or library, and they just did that, so I just continued to do that. Because I was like, yeah, that's a good idea. Why not? Anyways, data count. Data count comes in. It's supposed to count how many bytes we get from our Arch channel. We're going to see if our data count is less than our buffer size. If it is, increment it by 1. If it isn't, set it to 1. We now take that increment. 1 minus 1, that's 0. If we counted this one up to a greater value, like 3, 3 minus 1 is 2. If we pass 3 to here, this is also 2. We're trying to see if this is received by our serial line, the null terminator. But if we put 2 here, if we put 2 here, no, sorry, 2 here, no, 3 here rather, we can be like, 3 is less than 4. So this is fine. Let's loop back around. Then you'd be like, uh-oh, 3 is not less than 3. Therefore, go to else and set this to 1. And you would be in an infinite loop, or you just overwrite data. I think you would overwrite data. Let's try this. Let's try this. So let's go ahead and make it and flash it. Okay. Let's see. We got 7. We got 7 because it looped around. Our max data size is, if I do 4 here, it's gonna say 4. Yeah. Max data size is making 2. 1 less than it. There's definitely an easier way to be doing this. I feel like I've done something like this before. It's not coming right. Zero's coming in. I'm getting kind of annoyed with this, the freaking Git extension. It just keeps popping up when I'm not looking for it. Okay, anyways. Data comes in. We are close right there. Maybe this is data count. It should exit with 4. That's the ideal. It should exit with buffer size. Yeah, I should exit with buffer size. Buffer size, which is 3 in this case. Well, I mean, I guess I don't know what kind of behavior I was even looking for. I mean, we were overflowed, so I guess I wanted to overwrite, which it did. It did overwrite. Okay. I don't think there's an issue here. I don't think there's an issue here at all. If I go to... If I make this back what it was... I think that is better. There we go. If we send 1, 2, you know, 1, 2 goes through, 1, 2, 3 should go through. But as soon as you hit 4, it doesn't know what to do. You hit 5, it doesn't know what to do even harder. 6 doesn't know what to do even harder. 7 doesn't know what to do even harder. I would have expected it to send at least 1, 2, 3. Oh, in fact, it just is broken. It's in a loop. Interesting. Interesting. Wait. Oh. I need to set this back to 0. No, hold on. I just noticed something. I was staring at this right here. I was staring at my board. And I was seeing that when I send a message, it's not actually blinking the way I was thinking it would. So I send it. Right, I send out 1, 2, 3, and I receive 1, 2, 3 back. And I see it just going. This LED, what I intended was for it to toggle on and then off at the end of the entire packet, not multiple times, but I'm seeing it going boop, 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 boop. You know, on, off, on, off. Which would have to mean we're somehow going through this code multiple times. And data count gets put back to 0 right before re-entering. Toggle output. You take the pin, you turn it off. It has to be with a condition. I feel like that's happening multiple times. When you exit out of this, data count gets put back to 0. Oh, that's it. 0. Oh gosh, what is this reading? Oh geez, we put a memory leak. If you take data count and you subtract 0 from it, what's 0 minus 1 from an unsigned integer value? That's a big number. That's a big old number. Okay. Big. Wait, but... Oh, actually, maybe not. Hold on. In the do while, it should enter into here first, right? It should try it at least once before checking the while, so never mind. Maybe not quite the big number I was thinking of. Yeah. Darn. Okay. Right, could the bug be? No big, only big sad. Yeah, that's a better way to put it. Big sad. I feel like this is just not elegant. The way this is going about, this doesn't feel right. The intuition is kicking in. It just feels off. What's the core of it? Whenever I get stuck, I need to draw it out. That's what I like to do, at least. Oh, the tablet turned off. Let's go ahead and fix that real quick. Touch on. Okay. T-draw. That's gotta be an emote. We need that. Act. I need to start making some emotes. Now that I have this drawing tablet, I can make a big T-Rich emote. T-Rich, the person. My big muscles. With the eyes right here. T-Pour. Oh yeah, T-Pour is needed as well. There's my nose right there. The muscles, yeah. No, this works. This works. Somehow I need to make a hairline out of this. I don't even know how. Yeah, I don't know. Those do not look like muscles. What do you mean? There's like veins in them and stuff. Those are muscles. I also have calf muscles. I have big calf muscles, you know? And feet too. I am jacked. I'm very jacked. I also have some nice abs here too. Who knew so much could come out of my name? Yeah, I mean, I don't make the rules. That's just how I am. I also have really jacked wrists. Oh, that doesn't quite look what I, what I thought. Okay, never mind. Looks like more like I'm flipping off everybody. Make this an emote. So how would I even do that? Let's see. Do a screen capture maybe? Yeah, I'll do screen capture. Let me erase these eyes to make them a little bit better. Because I know I can. Let's do the shape, ink to shape. Okay. Circle. Circle. That's a square. That's cursed. I got a square eye. If you're a Pokemon, this would be my final evolution. No, that's not the final. This is the starter. You're not ready for the final. Oh shoot. I don't know why it's not doing that. Yeah, I have ink shape selected. Come on. Come on now. Alright, one last try. Be ultra precise. Very precise. Okay, whatever. That's fine. That's fine. That's fine. We're just gonna take a quick screenshot of this. Save that for later. Have you ever seen? Of course I've seen Foss's Home for Imaginary Friends. That's a classic. That's such a classic. Okay. Just gonna go ahead and put that in there. Boom. That can be an emote for later. Alright. So, what was I even doing again? This definitely shows something. Oh wow, look at that circle now. Now it's like the Leonardo, not Leonardo, wait, is it? No, not Leonardo da Vinci. Wait. Yeah, Leonardo da Vinci. It's like the Leonardo da Vinci, like, perfect proportions of a man or something like that. For some reason, I couldn't remember if it was Leonardo da Vinci or DiCaprio. Like, I was getting the names confused. Yes, I was about to say DiCaprio. It's too fun. Too fun. Oh, there we go. Alright. I did save it. I had to think hard about it, but we're good. So, the core of what I want to do is I have buff. Okay? I have buff. In buff. Okay, that's some size. And its size does matter, as a matter of fact. And there is a while loop of some sort. Some kind of loop, actually, we should just say. That needs to loop through. Let's say loop. What the heck? Oh, I have the ink the shape mode on. Okay, some loop that reads data, reads a byte, needs to read a byte, and then store a byte. And this should be going on until you see null terminator. Is that it? Is it this? Yeah, I think it's this. Null terminator or greater than size. I just realized I am writing on top of chat. So I'm gonna do an audible here and shift it on over. Wow, look at that. It fits perfectly right in there. Okay. Alright, good luck. Good luck and good night. Good night. Jacob. Good luck. Good night. I do this thing where I write my words out loud. It's just fun to do. Alrighty. So we need a loop. We read a byte, we store a byte. And then once we do that, we then send bytes. Send all bytes. We send all bytes. Here's what we need to do. If we had it in a regular while loop, while, like if we said while, oh, I'm doing it again. While, say while data count is less than max, let's say. I mean, we could make it like this to start out. So while it's less than the max, we can make it where it reads byte, read byte, store byte, and then we could make data count increment, so that way on the next time it's bigger, right? And then what we gotta do? We gotta send, and like let's make data count back to 0 up here. Data count equals 0 plus plus. Send buff, and we're gonna pass it data count. Let's erase this. Make it like this so we know it's a function. Okay, I think this would have been better. Some pseudocode like that. Something like that. Let's try that out. I mean, in this case, at least you're forcing it to just try and write until I can't write anymore. We're going to replace this with while data buff. Actually, data count plus some buff size. I can make it like this. Also these data count plus plus. The store and the read is in the same command, so we don't need to write it twice, but we have to do. And then this should just be data count So it gets to 3, right? It gets to 3, 3 is less than this, and then it gets to 4, and I'll exit and do this stuff. But let's see, 0, that'd be 1. Yeah, okay, so then this is what we do. We do, Huh. I was thinking about putting an if statement in here, saying if you got a null terminal, then you should leave. You should leave. Is it ever gonna be? No, it can't be. Yeah, never mind. Yeah. Alright. If data buff data count -1 is equal to this null terminator, then break. To me, that seems fine. Make you start program. See how it works. So we send 3, we send 3, we send 4, we send 3, we send 3, we send 2 again, we send nothing. It breaks. It's broken. We broke it. We can't save it. Oh wait. Hold on. No, damn it. Okay, I was thinking like it was just saving the last data, but that's not quite true. When I say 1, 2, 3, my max is 3. Right? 1, 2, 3. That means I can't take any more data. No more data. I do not know, if I'm being honest. I'm not sure. I definitely can figure it out, but I'm not sure. This is having the same behavior as before. Our issue is as soon as we hit the max amount of data, we have this null terminator in it. And then it gets in a stuck state where it's probably like the first data has this in it, so it's just breaking over and over again. At least that's my guess. Yeah, that's my guess. So if I take this off, we need to reset it. Yeah, we need to reset it. So I'll send this data, you know. Data. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. 2, 3, 4. Oh, then it just gets in a stuck state completely. So I said 1, 2, 3, 4, and it says 1, 2, 3. Oh, what the heck? You can move stuff around? Oh, interesting. Well, that kind of screwed my data up. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Yeah, then it's supposed to be 3 again, but what's happening? I am sending it 1, 2, 3. 1, 2, 3 is coming in. Right, 1, 2, 3 is coming in. And then we're breaking or exiting because our buffer size is, our data count's greater than our buffer size. So then our data count is 4 here. So our buffer size is 3. 4 goes into here. We display 3. And then we display 3. And then we toggle our LED. And then we come back to the top. Our data count becomes 0. We still have data in... Okay, I think I see what's going on here. We still have data in the buffer. I think... What if we remove this? We still have data in the buffer because of the hardware it's collecting in the FIFO. Because it has more... Wait, but then it's looping back around. 1, 2, 3, 4... This shit, how is it getting 1 and 2? That's where I'm not quite getting it. I am curious to see what happens though when I remove the null terminator. Alright, so if we clear this and send... Oh, it's the same thing. Okay, it's the same bug. Data count. Data count 0. It just grows until you can't grow anymore. And then it sends it all. Easy, right? Well, that's where you're wrong. Because it's not. It doesn't think like we think. It thinks its own way. Let's bring it into this function here. 3 is our data length. Or is it 4? Oh, hold on. That could be it. Is it 3 or is it 4? If this is, by the end of this, 4, which it is, 4 gets passed into here. 4 comes into this function, which I think we already went down this path. 4 is here, 4, 3 is less than 4. 0, 1, 2, 3. 0, 1, 2, 3. That's 4 values. We're in unrestricted data. That's not right. We need this right here. Boom, bada bing. We need -1. At least I think. So let's make it easy first. Okay, we'll send 3. What's this about? Data count 0. Comes in 0. Comes in 1. Comes in 2. Comes in 3. This is now 4. 4 comes up to here. 4 is less than... Oh, I see. Not quite right. 0 comes in. 1 comes in. 2 comes in. 3 comes out. Because 3 is not less than 3. So data count is 3 right now. This was not the key. This was not the key. 3 comes out on 3. 3 comes into here. where we at? Oh yeah, 3 comes into here. 3 is passed into here. 0, 1, 2. And then it's the 3. It exits. What is? Look at all these extra steps I don't do in the loop. I do this in my send for TX, but I don't do it for the loop. Interesting. This is a side tangent, but I believe we should be removing this. At the very least. Okay. Wait. Until. Isn't it until. Wait until. Data register is empty. Same thing can be said down here. Wait until data register is empty. Okay. We're gonna wait. We're gonna write. We're gonna wait. We're gonna clean up. These are different compared to my regular send. Yeah. It's TX. It's interesting that I can just loop through this, like send out, go back, send out, go back, send out. Like, why would this not need to be? I think I need to look at the data sheet really quick, but why would that not need to be checked every time? I'm like convinced that that's right. Probably a control register. Actually, it'd say back here ISR. ISR, and it's the TC number 6. When TDN is 0, flag is set when transmission of frame containing data is complete, and when TXE/FE is set. When TDN is equal to the number of data in the TX FIFO, the TC flag is set when the FIFO is empty and TDN is reached. When the TDN is greater than the number, TDN remains cleared until the FIFO is filled again. To reach the program number of data to be transferred, when TDN is less than the number of data in TX FIFO, let's see. Cleared by software writing to 1. I guess that's why I did this. Or by writing to the register. Oh. Oh, let me see. Oh wait. Yeah, writing to this register. That's why I kept it out. I'm just going to write to it again. Okay. So let's remove this. This toggles that. some interesting behavior. So we're back at it, where right for this to be empty. Or it's definitely sending out stuff, so this is working in the sense that it's pushing out data. Because it would be stuck here if it wasn't. It is pushing out data. And it is writing new stuff to data. The data count is greater than that, and then it just goes to here to make sure that there's no more data. Which you could theoretically use this again. Just this one is maybe better. Oh, actually no, this is probably just talking about the data version. This doesn't mean everything's done. Alright, well, if sending out data, why might it be glitching? Do I get out the debugger? Because I think I'm pretty sure I need the debugger. It's just the easy way out, really. Just make sure it's in this mode. Okay, yeah. So we're gonna fire up the server once more. We're going to not commit. We're going to connect to the server. We're going to do target extend remote 3333 and let's see, let's put a few breakpoints. I think that's the best way to get through this. I think if we put a breakpoint on this line, on this line, or sorry, this line, okay, well, let's just start here. So we want to do breakpoints on 33. That's not what I wanted. Clear 33. Oh, clear 1. Clear break 1. Clear. Ay. 47. Oops. 47. Delete breakpoint. Oh, okay, I see. Alright. We want a breakpoint on main, so I'll do break main. Dot C, of course. 33. B. I spelled break wrong. I'm such a goober. Alright. Breakpoint 33, which is fine. And then we want a breakpoint inside of TX buff. Probably here. ESP UART dot C colon 162. No, oh, I had extra dot. Okay, I forgot to put an S. So then we do restart, yes. And then we do Control C, continuing. So now come over here and try and send. Which this should continue, but alright, so what is this? So if we print data count, be 0. Data count. Come on. 1. Halt. Oh. Is it not? Now I'm confused. What the heck? I am in receive char. Oh, okay. Yeah, continue. We continue. We send some data. We're gonna send 4 though. Let's see what it does. It's not breaking. Data RX. Let's see. What is that data RX? Dereference data RX. Oh, print. Dereferenced data RX. It's 3. If I do data RX 0, it's 3. If I do 1, it's 3. Kind of. It's hex 2, 3, 4. What is 4? Yeah, it should be garbage. I'm in no man's land. 3. What is going on? I turned off the ending, so it should be no carriage return. I even took off that check, I believe. Yeah, let's restart. This is getting wacky. Okay, so program started. I send. Okay. Yeah, okay. We're gonna print data count. This should be empty. And then we're also going to print, not print, but list. I don't know, we'll do print data buff 0. Alright, 1 is our first value. I know it's hard to see, unfortunately. This is too small a window. It can't be seen. I can't zoom it in. It's actually super annoying. Yeah, relevant. Only by chance, I think. Because if I go to 2, it has 3. If I go to 3, it has some unknown value. I think this is just because of the last time again, if I'm being honest. We're going to continue. The data count, I print data count, has now 1. Okay, that's fine. Breakpoint data count, print data count to verify. Okay, we're at 0. Print data buff 0. It's 5. Okay, that's right. 1 is 2. All right, it was left over. Good to know. 2 is 3. 3 is no man's land. 0. Back to 5. Okay, so we can continue. We're going to print out 1 now. Should have 6, which is good. 2 is 3. Okay, we're going to continue. Halted. We hit an exception. And I think it's because you're trying to access data in a region we're not allowed to go to. I'm like pretty certain that's what's happening. It's stopping us from doing so. Zero. We go in. Data count. 0. Check. It becomes 1. One is less than 3. 1 comes in here, you can access 1. This becomes 2. 2 is less than this. 2 comes into here, that's fine. 3. 3 is not less than this. You should be skipping this. Data count 3. Where am I at? If I hit Control C, where am I at? I'm just at another receive. Oh, did I send it out? Oh no, I didn't even send it out. It was stuck at 182. Can I go to this line? I'm pretty sure I can't. Oh, no. 182. Is it the RX char? Oh. So all the data is not getting shifted through. Wait until all data has been shifted through. Transfer char into RDR. All data has not been shifted through. At least I think. It's stuck. So if I go, what is this? 515 over. Brands use SARTs, shifted over ISR, and 15 over, it's 0. RxNE. RxNE. RxFNE. Search. Oops, wrong button. Search RxNE. Interesting. It's right here. Am I looking in the wrong? Oh, it's the same. It's the same spot. There's no difference. It's just they have a different name here. RX bit is set by hardware when the content of the shift register has been transferred to the data register. It is cleared by reading the data register. The flag can also be cleared by writing one to that register. Data is not received. Missing data? Shouldn't be. Is this supposed to be a parody with this? I don't think so. It's my init. Stop its data bits. Is there a parody thing? There has to be a parody thing. It's one of these registers. I feel like I wouldn't be responding if I was not in the parody. Even parody. Parody disabled. Yeah, that's what I thought. I'm actually getting out of my mouth. Okay, well, let's just restart and follow. Restart, yes. So we can do it at least twice. We'll go 1, 2, 3, 4 again. Clear. Send. Continue. Continue. Oh, nope. Too many. Yes. 5, 6, 7, 8. Send. Continue once. Step. 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 we're stuck. We're stuck indefinitely. But why? Working with audio programmatically, yeah. Yeah, sorry, I just now noticed your comment, but yes. Basically, I'm nowhere at that step yet. But, essentially, see this here? This chip, you can program it, and I'm trying to make a drum machine based out of this chip. But to work with this chip, you need a just a basic amount of libraries to do basic tasks like send out messages serially, so you can do like printfs and stuff, send bytes over. You can write the analog signals, so you can make the waveforms, stuff like that. Have you ever gotten into that stuff before? Have you ever found the world of digital electronics? Registers, yep, exactly. You got it. You got it. Dealing with registers, but I'm trying to figure out a bug I'm dealing with right now. I'm sending out data and getting an infinite loop. And thanks to this handy little device right here, I'm able to use some logic, not logic, but I'm able to send data over to it and receive data to it, and then use GDB to try and see what variables are what at a given cycle. Null byte found. Yeah, I mean, you could say that. I mean, basically this is 0, so you're not wrong. There's a null byte found at this exact bit in the register. Thank you for the follow as well. Thank you. Anyways, the silly thing about this is this was working a little bit ago. Kind of working, I should say. And the thing is, this is just an example. This is just an example to test that my BSP is actually working. But the problem is, yeah, it sure is. This LED is blinking on its own though. This is more to verify my GDB setup. It's synced to the clock, I believe, for my debugging. But what should be happening is this blinks on and off when I send a message. It's not quite doing that. I need to figure out why though. And I've learned it's pretty hard to debug on the fly. It's kind of like whiteboard interviews. But, you know, what better way to practice that than just doing it all the time? By live streaming and talking through your thought process. So that's kind of what I'm doing here. I have some code that basically is supposed to receive a byte of data. Yeah, it can be. It can be very difficult. I'm guessing, do you have much experience in the embedded systems domain? You already are throwing out enough buzzwords to give me an idea that you might have some experience. Gotta figure out what's going on here though. In fact, conversating is giving me a little bit of a mental break. No, but you're working with large arrays and audio data stuff. So if you've been working with large arrays, immediately I think of, you know, SOC or FPGA land, data manipulation. Yeah, audio data stuff, again, I'm thinking of more the hardware applications of that. But if you're dealing with like a more higher level software point of view, where you're just calling APIs, I guess you can still be working with that data, just you're calling functions that you don't have to deal with anymore, which would change it up a bit. I don't know. I've been in the low level for a little bit now, and I've been liking it in terms of my career. It's a satisfying place to be in, but it's hard. Okay. What could I do? I think I'm going to turn off, the first thing I'm going to do is turn off this GitHub extensions right now, because it's annoying me every time I look at a line. I keep seeing this pop up. My commits. Is it my lens? Visualize code authorship. Yeah, it's this one. I just want to disable it for right now. 1-bit delta PCM is interesting. That's a new phrase to me. Pulse control modulation. So I'm gonna guess you're using 1-bit to modulate some signal. Just putting words together, but I don't actually know much about that. What's it used for? Okay, looks like that got rid of it, thank goodness. Yeah. Wait, is it required? I remember doing some modulation stuff back in college when I took a communications class. And to me, that seems like it'd be in that alley. But maybe that same technique can be applied to audio. The NES kind of audio. Oh, okay, I like that. I like that a lot. They use that kind of algorithm to reduce sound? I'd have to see. I gotta look that up. I haven't gotten to study too much about the techniques that were used in the past, I guess. My thought process is I'm kind of learning this as I go. I haven't had any DSP stuff outside of MATLAB, I guess. So like, I was kind of learning these theory as I make this thing. You know, what better way to learn something than use a project? Granted, I'm quite aware that the DSP realm can be quite difficult. But I like difficult projects quite a bit. I have no problem banging my head at something for a long time. That's why I'm doing this right now. It's not even a hard issue. It's just a silly bug, but that's part of it. But yeah, I mean, the simple music based off of constraints, it's cool. It's a cool thing. And when you're constrained by hardware in the past, in the 80s, 90s, creativity spawns out of those constraints, which is really inspiring. It's just like people can make stuff out of small amounts of things. It's like, first step one to make music, make the universe, you know? You want to make something small, have something huge. No audio limitation. Yeah, I could actually see that. I mean, I've been seeing it with just regular art as well. People talking about using, you know, pixel art. That's super popular in the modern era, even though it doesn't need to be. The technology is way past pixel art, but that style exists. Audio limitations when you're creating stuff, it forces you to be creative. You know, like I play quite a few different instruments, and I just can do, I mean, I guess it depends on what it is, right? If you got the acoustic guitar and you don't do any external effects, you're constrained to how it sounds, but maybe you can be creative with it. There's the whole finger picking, not finger picking, but like the rhythmic guitarists that are like slapping on the guitar while they're playing it and flicking it and hitting the headstock as well, getting new sounds out of it. They like have a drum beat while they're strumming, which is fun. I mean, when there's like the 808 machines, you have a fixed amount of sounds you can make, but people still made music from the 808 machine, and it was kind of endless with the different inspirations it caused to at least get the song structure going, and you could use it to continue your song. And then maybe if you want to change the style, then you can change the style. But like for me, I know that the Strokes or Julian Casablancas, like their whole first album started on the 808, and then they adapted it to be recorded on live drums. But like, I don't know, that's kind of where I'm coming from with the desire to make a drum machine, is that I prefer having hardware, and I like making music, and I have a hardware synth versus using like Ableton, and I have way more fun playing with the hardware synth than the software synth, even though they've modeled pretty much every single hardware that exists, that's mainstream at least, into Ableton as a, what do they call it, VCT or something like that. I don't know, just something about feeling the exact circuit rather than, I mean, MIDI controllers are good to try to simulate that, but like when you have the synthesizer, when you have the knobs, you're moving them around, you get the, what is it called, the detuning because of the heat, temperature, the wear over time, like you get that warm sound. It's just cool, which is really cool. And so I'm kind of like combining my professional skills with a hobby I have, seeing how they overlap a little bit. It's just cool. The only issue is implementing different audio algorithms. Stop using normal high quality PCM and WAV things. Hold on. I'm a little bit tired right now. Let me try and comprehend what you're saying. Is how you feel, I'm guessing, when you're implementing different audio algorithms. Oh, okay. It's like you want to make cool stuff, but it becomes too difficult. Is that what you're suggesting? Or am I misinterpreting what you're going for? The funny thing is, this UART, I mean, do I even need this UART to get started? You're doing AD PCM. Well, let's see what AD PCM is. I have it here. AD PCM. Versus PCM. Let's see what this is about. Voice compression. The voltage of audio sampled when digitizing. For PCM, each of the different digital values of encoding represents the same voltage change. Now this is just a different encoding scheme. Oh, okay, I think I have read about this. Because I recall reading about something that was compared to PCM, I feel like I looked up a compression algorithm. Is PCM just an encoder, though? There are subclasses of the Microsoft WAV file format. Well, let's see. Sample rate 8 bits per sample versus 4 bits per sample. So you have less data per sample. Let's compress. Oh yeah, lower quality, longer duration, more efficient. Less efficient, I'm guessing, because you have less bits per sample, less data. Wait, but more efficient. Well, hold on. Let's just continue. Low frequencies properly reduced, but high frequencies are produced with distortions, so it favors lower frequencies. Better for long distance transmission. Oh, okay. So it's kind of like a compressed version, which would make sense. I mean, you're like filtering out the high frequency stuff because you have lower bandwidth. So what exactly are you doing then? Is this do you make VCTs and stuff? Or you said what did you say? Large arrays and audio data stuff. Okay. So you're just transferring data around, but you need it to be containerized or be part of this standard. Do you come across many bugs when doing this? It's ideal when you require high quality audio, whereas yes, okay. Adaptive differential pulse. I mean, everything has bugs, right? My favorite is most bugs were just memory related bugs. Okay, like you're out of bounds, you get memory leaks, you're accessing memory too slow. I think what are some memory bugs that we'll figure. Wow, it's funny we talk about this stuff. This song sounds like it's from an era of the 80s where you have your synths popping off. But I doubt this was even made in that time. It's just a random song off of Epidemic Sound. This example is not solid. I'm mostly just thinking, like, do I deal with this now? I kind of feel like I don't need to. This is just a nice to have. And the reality, my example needs to show that I can receive data and I can send data. This is just trying to support sending a variable length. You've exported data that was basically straight from a memory leak. So you pushed data out that wasn't. You're accessing data that you weren't supposed to, essentially, right? Yeah. That's not good. I don't think I've quite come across any bug like that in my line of work. I'm thinking about it. I feel like a majority of my stuff has been race conditions. Somehow it didn't segfault. Yeah, that's kind of crazy, huh? It just let you go somewhere that you weren't supposed to. Is being a little bit more free, giving you a looser guideline. But yeah, I'd say a lot of my stuff has been race conditions or hardware issues, power problems, or boards breaking, that kind of side of things. Not with this stuff, but my actual job outside of this. Yeah. But I could see, you know, when you're dealing with audio, it is just a lot of memory. I mean, it's all just a waveform that's stored in a giant array. I mean, it depends how big the array is, I guess. Trying to remember what, like, I did one synthesizer that was super basic. It was just wavetable based. A lot of data to process too, yeah. And that's the part that, like, I want to get more into. Like, the idea that I have, which is slow. Yeah, I could totally see it being slow, especially with, like, some of the algorithms you're trying to apply over it. Actually, now I think about it, I did take a class where we were doing video compression, and I didn't get to see it in real time, but the algorithms themselves, I think it was all based off of DFT, discrete Fourier transform. Memory access trickery, yeah, with like DMAs or something, or circular buffers, I'm guessing, something like that. I mean, that was a trick that I used to speed up pointer arithmetic technique. Okay. Yeah, I mean, I think I used 2 pointers that just like walked around each other in memory. When one was getting closer to filling, the other one was moving, and they would just like keep going around in a circle. Pretty sure that was a circular buffer. But anyways, yeah, like the algorithms that you can use, I'm very aware that they can take long. I just don't know how long they would take on this processor. And that's where I'm a little bit intrigued about. The pointer arithmetic technique? Oh. Like, are you talking, is that a thing specifically? Like, it's called pointer arithmetic technique? Or you just, I mean, pointer arithmetic, that just has to be plus minus subtraction. That's the same thing. Plus minus multiplication division on the pointer. So I guess yeah, you're just talking about that kind of stuff in general, I see. Yeah, I could definitely see that. So then I gotta ask, is most of the stuff given to you, like what kind of hardware, your algorithms or the things you're working on, what is that running? What platform? Talking about desktops, talking about single board computers with SoC on it, talking about microcontrollers, FPGAs. I mean, I'm gonna guess not the FPGA. Sounds like you're coding, so it has to run C or C++. And it could also be on, I don't know. Have you heard of, what's that framework? Is it Juice? Have you heard of Juice? Is that what you use? Maybe Juice is just for the audio effect people that make Ableton plugins. PCs, okay. Yeah, that makes sense. I feel like that's the majority of people that are using audio for like musical purposes would be through PC nowadays. Because a lot of it is Ableton effects or Fruity Loops. Like the things specifically you're talking about is audio compression, so it's like users listening to audio or sending audio via wires at least. That's pretty fun though. The reason behind all this is just combat loading times compared to other solutions. I see. So make the audio more compressed or make it less demanding so that way things load faster. Yeah, that would make sense. They always find which technique or which part of the project takes the most effort or computation time. See how you can balance that out. Yeah, that definitely makes sense. I mean, like the magnitude of the operations required to do some of the audio processing is way more. Because of what I was talking about with the DFT, like frequency domain stuff, talking about convolution, that's going to be way more. Multiplying accumulators, like, yeah, I mean, forget it. It's better to have hardware that can at least support it. And design for it. Now we're on PCs, so the processors are definitely way stronger, but at the end of the day, it still takes so long. Shouldn't have the compiler generate way more CPU instructions just to get the index of yeah, no kidding, that's true. Right? You should be able to just grab the index. It should just be adding to an address, which you could totally do. And that's where your pointer arithmetic comes in, right? Just add to the address. That's literally one instruction, right? You don't need to go fetch it. Go over here, pull like 5, I don't know how many more instructions, but like that's something you're doing every single cycle too. More than every cycle, you're doing it for the entire buffer. Yeah, you're just adding an address. Right, exactly. I recently learned that's how switch cases work in C. You just add the value to the instruction for each case, and that makes them already faster than if-else's because of that. But I think address arithmetic is pretty cool stuff. Like, I really like those clever things about low-level register, low-level programming. It's a lot of nerdy shit, just nerdy solutions, but it works, and like I can really appreciate that. And I think only people that actually get to work in it appreciate the nuances that exist in these low-level designs. Or even like just real-time stuff. Like you have to be super smart about what you're doing. What is it? SIMD or AVX? Isn't that the simple instruction set or something? Right? Like assembly, or maybe not. Maybe I'm confusing the acronym with something else. What is that? What's AVX? How about that? AVX. I'm just kidding. It's probably not that. Okay, yeah. So assembly instructions that let you do how do you say this? That let you do more instructions for these kinds of DSP. It's just like a additional subset, not a subset, but like superset of instructions. Advanced vector extensions. Oh yeah, here we go. Simple instruction, multiple data. Oh, that's right. Yeah, I have come across that acronym. Yep. You get to parallelize essentially a bunch of data processing all into the one instruction. Yeah, that's definitely relevant for your kind of situation. Yeah, I don't think that's really gonna. Well, maybe this is in my chip. I don't know. It's all this at this point. This kind of stuff would be in the ARM core, not even the microcontroller outer core. Difficult to use since I never used it before. I mean, yeah, that's valid. Yeah, I mean, from your point of view, you need to call a certain compiler flag, I'm guessing, to enable these, right? Something like this, and then maybe you would need to go in and force an assembly code. Yeah, I bet. Yeah. Yeah, you would have to hope that they have some kind of compiler flag. It's my only guess, because otherwise you're in this domain where you're like putting in special tags in your code where it's just like this random little like assembly block. Which, yeah, again, I could see why. Yeah, I'm curious if I'll ever need to get into that. I really don't know. Oh yeah. And if you're doing a standard library, yeah, you definitely are trying not to use processor specific instructions like that. I mean, in terms of x86, yeah, you're right. You definitely don't want to be doing that, because it's not even going to compare probably to your ARM future project or future port. Stick to standard instruction set, yeah. Well, the thing is, it can be done with it, right? It's just not necessary to do it if there's other ways to get around it. It sounds like you're able to have achieved what you needed. And obviously there's probably other programs that are doing a similar thing that whatever yours is doing does. But then again, you don't know if they used these SIMD or AVX stuff. It's still cool though. Yeah, it's all cool to me. I just learn more and more about like all the things that go on behind the scenes and processors, and like that's always been my goal, is just learn more about the stuff I use every day. It's just neat. 100 megabit file in 36 milliseconds. Let me see. Do I have a good intuition on file transfer size? Well, it's not fair to compare. It depends what your signal is. So you're over a PCM. Is that considered the standard at which it is like not baud rate, but like your transferring protocol, 16-bit PCM? That sounds like a transferring protocol. So ACM, or whatever the other one is, and PCM, they're transferring protocols. I think that sounds right. So you're using it to transfer data between hardware. Am I right? Like you connect to a different piece of hardware, that, like through a like a PCIe port or something? Or is this just between files? 16-bit PCM to 32-bit for compatibility. Okay, now I'm a little bit lost. I still need to figure out really quick. So it's the audio format. Method for converting analog to digital. PCM audio recorded on DVDs and 2-channel. It's you sampling it. It looks like is a standard to sample. Oh, go back. What's this? Oh. Okay. PWM. I've used PWM plenty of times. PCM is for digital data. So I've done AM and FM. I learned about PM. But these were all analog signals with analog data. You have digital data. Over an analog carrier that goes out into the air. But you have digital carriers now, so this is how you carry some kind of data in the digital domain. This is how you carry analog data, which makes sense because you go from 0 to 100% duty cycle with the PWM, so your pulse width is what you're actually changing. Pulse amplitude, you're encoding data into that. Pulse position, not quite sure what that one's about, but pulse coding. So you're just encoding data into data. This is showing an analog signal. Digital data. Yes. Yes, we love that. I want to see a better picture. Images is probably the best way I'll figure this out. What we got here? So you are passing this value. Game engines, okay. Actually using some software in my case, game engines. Yeah. This is where I was thinking, because when it comes to games, loading times, you gave that context. I heard that the budget or the allocated, like, yeah, we'll just say budget, memory budget, processing budget for audio, at least for some bigger game studios or some games, like they try to pull it away from the audio stuff, which can hurt the audio stuff. So you have to be even more clever because you have the tightest constraints, because the other parts of the game, they want to be using more for those parts and less for the audio. And I mean, shoot, you're forced, your hand was forced, you figured out a better way to do it. And well, I guess you found the functions and you changed up how you use those functions. Maybe you changed the arrays, I guess. But okay, that's still pretty cool though. Like, I learned that depends on what the game is doing with the audio, but like developing like an audio engine is super sophisticated stuff. It's super clever. It's so crazy like how much thought and engineering has to go into creating these experiences for people like playing games, man. It's really it's a underappreciated thing for people that don't know much about it. You change the encoding part of things. Okay. File sizes. Oh, I see. So you're bringing file sizes down a bit by maybe compressing it with a different algorithm or something. Okay, so this one looks like you are taking an analog signal and then you're encoding this analog signal into digital using digital. That's so crazy. Digital into digital. The closest thing I was going to get to this was probably a protocol called I2S. 16-bit audio is quite large in file sizes, basically at megabytes average. Just thinking off of audios that I've seen, I mean, that sounds right. It does sound right, yeah. I mean, if I go to my device manager right now and look at my audio input for my headset, properties, kilobyte. Wow, you're talking about a whole 100 times smaller or 1,000 times smaller. That's huge. That's a huge difference. Yeah, that saves so much. Are you kidding? No wonder. I'll be right back. here we go. Look, there's a PCM unit. A dedicated piece of hardware. At least in an older sound system. Just for recording. You take the analog input, it goes into a PCM unit, which is encoding it into PCM. And then that goes to a cassette recorder. Okay, I am now seeing where this is applied. From my point of view, would be receiving PCMs from a codec, probably. And in your case, you might even be sending it to a codec. I mean, likely you are. Or at least your game engine would at the end of the day. It's gotta talk to the codec, which would go to the user's speakers or audio system. Okay, but you say, okay, 1-bit Delta PCM can go to just 10 kilobytes because you're just working with bits. I see. Instead of packs of bytes, yeah, that makes a lot of sense. I mean, it was saying what, 8 versus halving it at least. But yeah, I mean, shoot. I know, it's pretty cool stuff. Like, I want to get to this part in my project. The issue is I gotta scaffold it up. It's like I'm building an engine from scratch. I mean, honestly, that is kind of what I'm doing, which is kind of insane to think about. Unfortunately, when it comes to like the embedded world, I spend a lot of time on Reddit, you know. I search on the internet, and the meta when it comes to these like fundamental API libraries is that the vendors of these chips, sometimes the libraries are full of bugs still, and they have poor support. Granted, this is a very popular chipset from a popular company, ST Microelectronics, or Microelectronics, I think. So they should be valuable. However, I'm also trying to learn more. Because I found when I was using APIs, I wasn't fully getting the picture. I was losing understanding on how some of these low-level things work. And when it comes to debugging, like, I think that understanding under the hood is super valuable. Super slow, and not great for being a fast producer of things, but like, I don't know, when you can learn under the hood, you can figure out problems a little bit easier, I think. And at least so far, it's been tolerable. It hasn't been a bad experience. I'm just at a silly bug right now, and also just it's late, so my brain, after working my full 9 to 5 and then going into a second 9 to 5, I was a little bit worn out. It's honestly, it's more fun just getting to talk to people online, you know. Like, I can't really share these hobbies with people too much in my real life outside of work. Like, I don't know, I find that what I'm working on is very niche, so I figured I'd stream online and find other people who had some kind of overlapping. It's just fun to talk about this stuff, fun to nerd out, geek out. So then, okay, if you're working on a game, is this part of what's the engine y'all are using? I've tried out game dev a little bit, but nothing outside of a Lua 2D game. On like, I think it was just a simple 2D engine called Love or something like that. Unity. Okay. What is a managed language, but unmanaged is more fun. What do you mean by managed language? Like it's all in C++ or C#? Is that what you mean? Or is it you going for something else? C#, yeah, okay, I see, yeah. That's what I've heard. It's, so you have to kind of like just go all in into their language, which kind of pinholes you a little bit if you ever wanted to try a different engine, but like, you know, you've done it in C++. Oh wait, so the C# is calling a C++ engine, or not engine, sorry, library. I guess it doesn't matter at the end of the day if it has some API hooks. Yeah, I guess that doesn't matter at the end of the day because it's C++. Yeah, native. Oh, that makes a lot of sense. Yeah, it's probably for some Windows drivers. Yeah, that makes a lot of sense because again, you're talking about the PCM. Like, you have to use whatever the computer gives you. Like that's where I come in. That's the stuff I like to do. Make the computer do the things. For example, I'm sending serial data, but it's just a very simple packet of 8 bytes or 8 bits. Going low level, you bet. You bet. Yeah, I mean, it's hard to do low level stuff on Windows even. Like, I don't know. I feel like you have to be able to write Windows drivers. I know nothing about it. I just come from maybe using Linux stuff where you're able to access everything. It's not restricted off. I wonder if Windows restricts you from touching any of that stuff as a developer and you just kind of rely on the drivers that they made themselves. I feel like you have to have some kind of communication with them, because if you make like a new device, it probably just has to fit to some communication standard, but like, you know, PCI is meant to be avoided use. I always kind of avoided use of Windows API stuff a lot. So the things that you're using, they're Unity's drivers then, not Windows. Also, it makes sense, right? If you're trying to make it cross-platform, you can't. If you're maybe cross, okay, I guess now I think about it, cross-platform doesn't necessarily have to be cross-OS. But Unity, you know, they tried to put it's a cross-platform library. Okay, so then yeah, then you're just fine using their stuff as much as you can. But doesn't mean cross OS 2. Yeah, okay, that makes sense. Are we talking about even like getting to the phone stage of cross-platform, or just? Oh no, you said PCs. Yeah, that makes sense. Yeah, I'm not too familiar with like how easy or not the Unity engine makes it for transferring your game across platforms. ARM-based one because Apple Silicon. Okay, I see. I was inferring that's what you meant by ARM, because I was trying to think if there was like Surface Pros, if they were built on ARM chips. I couldn't remember or not, but like the main ARM cores that I'm aware of are the Apple ones, Apple chips, and it's a big market for Apple users. What shall I do? I think 24-bit type? That's like extreme audio file stuff. 3 bytes. Okay. 3 byte. Yeah, thanks. You'll make your own 3 byte type. That's still a lot of bits for analog signal. So like put in perspective, I'm mostly used to working with like probably 10 to 12-bit stuff, which is already way lower than the 16-bit audio you're talking about, and 24 even more so. But the fact that you brought that up makes me kind of intrigued on what is even possible out of my chip, because I was debating this fact of, do I just use the onboard DAC, digital analog converter, or do I try and work with an external codec that's a little bit stronger? Let me see. Let me go to the, let me try and see here. DAC. Yeah, see, this is 12-bit. We got 12-bit or even 8-bit, but I'll probably use 12-bit. And they have 2 channels for stereo. But like, talking about 24-bit, jeez. Let me see, let me put some new background music on. Seems that I ran out. Surprised this program isn't set up to just constantly play background music. Oh, here we go. A 12-bit type. Yeah, I mean, I don't know how it sounds, to be honest. I'm kind of curious. Honestly, I am curious to hear what it's like. I mean, I put, okay, thinking about it, in the simple synthesizer I did with 12-bit audio, I mean, granted, it was just like a pure sine wave, right? It sounded clean. I just don't know how it sounds when you start piling everything into it in terms of just all sound. A perfect sine wave is gonna sound clean. Your noise floor. Oh yeah, that's true. Yeah, not as much as 8-bit. Yeah, you're like diminishing returns for sure at a certain point. I just don't know if 12-bit is enough for me to care, at least in my stuff. I'm not too sure at the moment. I would say people are more critical in games when it comes to audio than, well, you know what? No, instruments, I feel like you have to have it be pretty tuned too. With games, audio does matter as well. Audio in general is just definitely matters a lot. Let's just say that. Just say that. Okay, maybe this is what I'll do. You know, you got me excited about audio. I feel like I just need to, you know, just pause here on the UART protocol and get into the DAC. Get back into the DAC. So let me commit what I have here. Let me commit what I have here so I can. Oh. Pure digital. Yeah, it is pure. At least on this one, it's pure. Oops. Actually, no, it's fine. Okay. How do I want to do this? I'm thinking I need to make a new branch. By the way, I was always curious when it comes to game design. Are you in a team or are you doing this by yourself? Because I was curious with the version control situation. You're doing it solo? Okay, I guess with version control, you maybe don't need to do as much of a widespread organization. Do you just have it like saved in a workspace locally, or does it upload to some cloud? I don't know if Unity has that built in or anything, or if you back up stuff yourself. Let's see, dev view. I'm thinking I want to branch off of main instead of branching off of this. Back things on your drives. Yeah, I guess that makes a lot of sense for a solo project. Are you doing it where you're buying assets? Are you doing the art yourself too and the music? Like, are you doing everything yourself, or are you getting assets to help along the journey? It sounds like we've been talking about the programming side. Yes. Okay. Yeah. I don't think like doing all that stuff. You're making custom assets yourself. Oh wow. Okay. Wow. That is very impressive. Because I was about to say, I feel like that's a lot of work, but you can take a lot of pride in that too. You know, there are multiple classic indie game stories that have those like holistically designed by the creator, and it's just they get way more appreciation, I feel like, when they're like that. It's just like in my case, more of an endeavor when I could, use the asset, use the library. But I just, the passion, I go with my gut, and the gut is to go for the passion direction. Okay, let me do my commit. Well, it's on my mind. Do this. Sign it. Have you ever used Git before, though? Like, I don't really know how helpful it would be for a game. That's what I'm getting at. I think you've used Git before. Yeah, I guess it's helpful for code, right? Files in general, too. Yeah, it definitely could be helpful still, thinking about it. Yeah. Okay. That's for open source stuff. Okay, to pull open source stuff. Yeah, that makes sense. That makes a lot of sense. So, let's see, saving progress on designing, on solving, I should say. Example, bug where program hangs after max size -1 byte is received. All right. Git push origin dev uart. So what I'm doing here is just going to change my branch because I have a few branches. I'm going to make a new branch off of main, so stable code. So we'll do git checkout -b. We'll call this dev DAC, where we get to develop our DAC files. And then we can, like this, these files, they exist. That's interesting. Why do they exist? I was not expecting them to exist. I think if I do git pull, git fetch dash all. Oh yeah? What kind of processing do you want to do? Like compression, reverb? Are you gonna use? I'm guessing there's probably some audio effects libraries that exist, right? Surprise. What is this? So this is a yellow, or not yellow. This is a turquoise folder, which makes me believe it is files that have no Git history. Maybe not. Yeah, I didn't actually hit a playlist. Let's go for this mellow mood one. Compression to OGG for even smaller sizes. OGG Vorbis. Now I gotta look that up. What is that? OGG Vorbis. It's another compression. It's an open source one too. That's cool. General purpose compressed audio for mid to high quality. Okay. Okay. So then, yeah, because you have it. So you would be taking the data that's coming in to your program and then pushing it into another compressor to make it even smaller in size. Dang, okay. And then when the user is like loading up a level, they access some file that's uncompressed of that sound, I guess. That's pretty cool. So then, yeah, you'd get even, well, I guess would your load times be faster? It'd be faster loading the compressed files, but you have to uncompress it eventually. Oh, okay. Okay, so you're gonna stick with the 80 PCM for now. Gives you what you need. I mean, yeah, you're in kilobyte range. I don't know if there's diminishing returns, you know. I don't know how much better it can get. Okay, we will change our file directory to BXP and change it to source. This is where I need to get the hardware out. A more complex question is very different. Yeah, I was gonna say something like that. Definitely seems way harder. Okay. I think for this one, I think on the side of this. I think on the side of my thing here, I have a headphone jack. Yeah, right here. I have a headphone jack, so I need to figure out a way to transfer that signal into my circuit. Yeah, transfer that into my circuit. I have a piece. And then I just need a cable. Let's say I do that. Let me think. Is that helpful? Do I see anything in my program? In terms of output. Well, that's cool. I can give it. Variety of signals. That's gonna be helpful. This is my first time really pushing this tool. pushing this tool for my engineering, which I'm excited to do. I need to figure out how that headphone jack works. Device manager? No, that's just choosing what you plugged in. It's not gonna be script, not gonna be protocol. Yeah, none of those are audio. Tracer. It's network, nope. Spectrum analyzer, nope. Oh, that would be neat. Slugger. Okay. Meter supplies. Nope. Scope. Head channel. Signal. That's one. Oh wow, you can do HDMI on this thing? You'll decode that? That's pretty cool. That's the real reason I got one of these things, so I could like decode signals way easier. Not really sure. I think I'd have to pull up the manual for this device I got here. But my assumption is you can pump a signal out the headphone jack, which would be at least amplified enough for headphones to drive off of. I guess I could try it actually right now. I have headphones. Waveforms, yeah. That's the funny enough, the tool itself is called waveforms. Well, okay, this is just channels. So. Let's see, let's look it up. Discovery Studio. Discovery. Wait, Digilant. Discovery Studio. Oh, wait, maybe that's the first one. Oh, yeah, it says Studio there. Okay. Manual? Oh, look at that. Records manual. I just don't happen to have the oscilloscope probes, unfortunately. Grounding circuit. Okay, it's not an issue for me. I'm not doing network stuff. Let's see, if I search maybe 3mm jack or headphone, nope. SDK, set of software libraries that can be used to develop custom applications that can control test. Oh yeah, this would be very handy for automated tests. Oh wow, yeah, that would be very handy. Would I ever do that? I'm not sure. Maybe if I was the consultant and wanted to have a setup where a code push would do it. Yeah, I mean, having without an oscilloscope, yeah, I mean, this thing acts like an oscilloscope, so I got lucky. I mean, that's not perfect by any means, but it'll do a lot, quite a bit. Oh, maybe it's here. I just need to figure out. I don't even know, man. Why would they just put that there? be kind of a better way to find this thing, to search for it, I'm thinking. What if I do this? Studio. What would it be called? Headphone jack? Audio adapter? That's not quite what I want. These are just regular headphones. In the loudspeaker impedance with Analog Discovery 2, I describe measuring the impedance of loudspeakers with the net. Oh, he used the tool to measure other stuff. Okay, never mind. Oh, here we go. Somebody's talking about it here. The headphone jack. Search. Get out of here. I don't want this pop up. Headphone.